In this course section, we're going to build a first basic app. An app which allows us to roll a dice and generate random values that are then reflected by an appropriate dice image in our app. And whilst the app, of course, is still fairly basic and not too fancy, it's an amazing app for getting started with Flutter and Dart, since it will allow us to write quite a bit of code and dive into many crucial Dart and Flutter features which you will need for the rest of this course and for basically all Flutter apps you're about to build. Because this course section is about exploring those core Flutter and Dart fundamentals which you will always need. It is about laying that solid foundation, diving into the core Flutter and Dart features and syntax. It is about making sure that you understand how you can write Flutter and Dart code. And this section is also about understanding that in the end, when building apps with Flutter, it's all about combining widgets, as you will learn in this section. And of course, you're going to learn what widgets are, how you can use them, and how you can build this app here step by step throughout this section. Now, before writing any Flutter or Dart code, I want to walk you through the important folders and files that were created when you created a new Flutter project. And for this section, you can either create a new Flutter project anywhere on your hard drive in the folder where you want to manage all your Flutter projects, for example, or you use that Flutter project which we created in the previous course section. Either way, you should make sure that you use the main.dart file which you find attached to this lecture to replace your main.dart file in the lib folder with. So the main.dart file in the lib folder in that project which you opened and which you now have open should be that main.dart file you find attached. And with that, you should have a new Flutter project, and the exact number of folders could change over time, but you should see a bunch of folders in there. And as you might have guessed already, the lib folder, for example, is a rather important folder, because it's that lib folder that contains your actual Dart code files. So the files in which you will store the Dart and Flutter code that makes up your application. At the moment in there, we got only one file, but as you will see throughout this section and the entire course, you can add multiple files in that folder, and you can then also combine these files to split your app code across multiple folders, which you simply typically do to keep your individual code files manageable and readable. So at the moment it's one file, and what's of course important about this file is that it ends with .dart. As mentioned in the first course section, Dart is the programming language that's used by Flutter to build apps with Flutter, and your code files must end with .dart, therefore also to tell Visual Studio Code, or whichever code editor you're using, that the content in that file is Dart code, which then allows the code editor to give you proper support and code formatting and highlighting of certain keywords, as you can see here on the right. Because that's one of the main ideas behind using a code editor, that you get some syntax highlighting, as it's called, so that certain keywords are highlighted, that it helps you catch typos and do many other things for you. And in order for the editor to properly support you, it of course must know in which language you're writing your code, and that file extension does help the code editor with that. So this main.dart file in the lib folder is important, and the lib folder therefore is important, but it of course is not the only file and folder you have in that project. Instead, you should also see an Android folder, you should see a build folder, you should see a Windows folder, a web folder, and also a couple of other folders, as you can see here. Now, these folders that carry platform names like Android or macOS or web or Windows simply contain platform-specific files. Typically, you don't need to do anything with the files in those folders. Instead, Flutter will change and configure those files for you when needed. So you don't need to do anything with the files and folders in those platform folders. They will be managed by Flutter, but they still are important because they are used under the hood when you run your Flutter project as an app on an Android or iOS simulator, and of course also later when you prepare your app for deployment, when you prepare it to be published to the Android store or the Apple App Store. So whenever you want to publish an app to a specific platform, the files and folders in the respective platform folder will become important. The build folder is also important, but also a folder in which you won't work. It only contains temporary files and output files generated by Flutter as it builds your app for different target platforms. So you shouldn't change anything in there, but it is an important folder that's also managed automatically for you by Flutter. Now in the test folder, you also find Dart files. But unlike the lib folder, the test folder is not a folder where you will write your main application code. Instead, in there, you could write code that tests your main application code. You could define automated tests, which can be very useful for catching errors early and for making sure that you don't have to test everything manually. Now, testing, automated testing, is an advanced topic and not something we will cover here in this course, but you can still keep this folder around even though we won't work in it. And then you also got many more files and also more folders up there. Now these folders, starting with a dot, simply hold some extra configuration. For example, the .idea folder contains some extra configuration for Android Studio. Dart tool contains some extra configuration for some, guess what, Dart tooling. And you don't need to tweak those configurations typically, so you can also ignore these folders here. And then when it comes to all these files down there, we got more configuration files. Gitignore is a file that's used by Git, this version control software, which you can use for managing code snapshots and going back to snapshots if you messed something up, for example. But you don't have to use Git when using Flutter, so you therefore can ignore that file. You also shouldn't delete it though. Now, .metadata is actually a file that is managed automatically by Flutter to keep track of some internal information and metadata about your project. So you should not delete that file, but you also shouldn't edit it. The analysis options YAML file configures some Flutter and Dart tooling that's being used by your code editor to show you warnings and errors in your code before you even run the app, which is amazing for catching errors early. And typically the default settings here should suffice and should give you everything you need. But once you're a bit more advanced, you could definitely dive into this file to tweak those settings to your likings, so that, for example, a certain style of writing your code is enforced so that you get warnings if you accidentally use another style or anything like that. This is advanced though and something you can therefore ignore initially. Now this first app IML file is another file that's managed by Flutter for you, and you can therefore ignore it. It contains more metadata and information for building your Flutter app for different platforms. The pubspec.log file is another managed file which you should ignore, but it is connected to this pubspec.yaml file, which is an important file that you may edit and that we will edit at certain points in this course. Because this pubspec.yaml file, for example, allows you to add third-party packages to your Flutter project. So if you want to add some feature to your app, which you don't want to build on your own because it's too cumbersome or complicated, but it's also not built into Flutter or Dart, you could bring in a third-party package, and you will see some examples for that throughout the course, and you would add those packages and refer to them inside of this pubspec.yaml file. So it's not a file you need to edit right now, but we will edit this file from time to time. For example, also in this section already to include images into our Flutter project. But again, you will see how that works once it's time for that. At the moment, you can ignore that file. Well, and the README file simply contains some general information about this project that was created, a short description, and some resources you can visit to dive deeper into Flutter, which you of course don't need because you have this course. And with that, you now have a first idea of what all these folders and files do. Of course, you will see many of these files and many settings in action throughout the course as we need them. So now that you got a first overview of these folders and files that were created as part of this new Flutter project, I want to take a closer look at this main.dart file, or to be precise, what happens to that file when you run your Flutter app on an emulator or on any device. As you can see, this main.dart file contains some code, which most likely looks quite cryptic to you at this point, since we haven't learned about this code yet. But of course, we will learn about writing this code and what this code does throughout this course section. But you can, of course, see that there is some code in that file. And I can tell you that this code, like this, would not be understood by Android or iOS devices. So what's not happening when you're running your Flutter app is that this code is simply copied onto the device and executed there. That's not what's happening. Instead, what is happening is that Dart, in the end, goes through this code file top to bottom and reads that code file from top to bottom. It parses this code file, as it's also called. So your code in your code files is parsed by Dart in the end when you're building your project for running it on a target platform. That's the first step. Your code is parsed and analyzed by Dart, because keep in mind, Dart is the actual programming language. Now, after your code has been parsed, it must be translated to a language that is understood by the target platforms, because, as I just mentioned, this code can't be executed like this on Android or iOS or other target platforms. Therefore, as a next step, after parsing the code is compiled by various Dart and Flutter tools, which simply means it's translated into some other code, some native iOS or Android machine code, so some code that is understood by iOS or Android or whichever target platform you are targeting. So the code you write with Dart and Flutter is translated into some other code, and that code is then in the end packaged up, bundled together into a highly optimized code bundle, and that code bundle is then executed on the devices you're shipping your project to. So on the mobile devices you are deploying your app to, for example. That is what happens to this Dart code. So you work with Dart and Flutter, but on the device something else is executed. And for that, the code which you write is parsed, so is read and analyzed from top to bottom before it's then compiled, and in the end it's then this compiled code that is executed on those target devices. So now that we know that this main Dart file gets parsed from top to bottom and in the end gets compiled to code that is understood by the target platforms, I want to take a closer look at what exactly we see in this file. And this lecture is primarily meant for students who have no or almost no prior programming experience. If you did work with other programming languages, you can skip this lecture here because we're not going to dive into Dart or Flutter specific features just yet. Instead, I want to generally explain what we see in this file. So what do we see here? We see a bunch of words, a bunch of lines of words, not really sentences, just combinations of words. And that in the end is what programming is all about. It is about combining different words to create statements, instructions that then tell the computer or a mobile device in the end what to do, what to show on the screen, what to do when a button is clicked, and so on. Now, of course, here we just got some code for a very basic app, which you saw before already. It doesn't do anything useful, but it does of course show something on the screen. It, for example, shows a main title and some text in the center of the screen. And this code here is responsible for that. Again, we're not going to dive into what exactly which line of code does here. We're not going to dive into the Dart or Flutter specifics, but instead I want to take a more general look at that code. And what you can see here is that we have that combination of words, and what's important to understand about these combinations of words, which then create these instructions, is that you have two main categories of words, you could say. The first category are so-called keywords, words that are built into a language that do or trigger very specific things in that language. For example, import would be a keyword built into Dart, which in the end connects this file to another file, but that's not too important. But the other category of words that you have are identifiers, words that you as a developer define yourselves. For example, my app here. We could have also named this meine App, which is the same in German. I would have to change this in some other parts of this code thereafter, but we could use this instead of my app. This does not have to be called my app here. On the other hand, import does have to be called import, because import is built into the language, my app is not. Now, throughout this course, you will of course learn all these important keywords, and you should definitely not learn them by heart. You should not go to the official documentation and try to memorize all these keywords. That's not how you learn a programming language. Instead, programming is all about solving problems, and in this course you will learn how to solve different problems and build different things, and along the way you will learn and see and automatically memorize which keywords are needed where to do different things. But it is important to be aware of these two main categories, and one of the main reasons for using a code editor like Visual Studio Code is that it helps you with detecting different kinds of words. For example, like all major code editors, Visual Studio Code has a built-in feature called syntax highlighting, which assigns different colors to different words. For example, extends and class and import are blue because they are keywords. Now, it does not just use blue for that. For example, return, which is pink, is also a keyword. And the reason for that simply is that different keywords can only be used in different places, and that's why we also have different colors here. For the moment, it's just important to recognize that different colors are being used for different kinds of words. Not one color per category, but definitely different color for different words and meanings. For example, yellow or this green light bluish color here would be used for identifiers. Again, just as with the keywords themselves, it's not important to learn which color is used for which word. That also wouldn't make any sense because you can use different themes in Visual Studio Code and that would then change the coloring of words. But it's simply important to understand that we have this syntax highlighting feature, which exists simply to make code more readable and easier to read for you as a developer. If everything would be white, it would be harder to quickly understand the meaning of code. In addition, code editors also help you catch typos. If I forget the A here, you see that the color changes, and that immediately shows me that something seems to be wrong. And of course, I also get some red squiggly lines to quickly show me that something is wrong with this line of code here. So that's another reason for using code editors. They help us catch certain kinds of errors whilst we're writing the code instead of having to wait until we try to run it and then see that it fails. But if we go back to the code, that's in the end what code is about combining different words, keywords and identifiers to create instructions that then do something. Now, of course, you don't know yet how these words can be combined. You don't know yet which instructions can be written. But that's of course exactly what you're going to learn throughout this course as you learn about Flutter and Dart. So now it's really time to get our hands dirty, write some code, and learn some Dart and Flutter. For that here, I'm in a new project, but you can also stick to the existing project that you have. But you should make sure that in the lib folder, in this main Dart file, you delete all the content that's inside of it. So that main.dart is an empty file, because we're going to write this app, which we're building in this course section here, from the ground up, step by step, all from scratch, so that we can really dive into all these core Flutter and Dart features. So how do we start in this empty main.dart file? How do we give Flutter and Dart some instructions to show something on the screen? Well, it all starts with one key instruction that you must have in every Flutter app you're building. And that's the run app instruction, which is written like this: run app, and then followed by parentheses and a semicolon. This is a so-called function. And functions are a core concept in Dart and actually in many programming languages. Functions are simply instructions that can be executed in your code, and you will soon learn how you can write your own custom instructions, your own custom functions therefore as well. Now, run app is a function, an instruction that is provided by Flutter, so not written by you, not built into Dart, the programming language, but provided by the Flutter framework. And this instruction, as its name suggests, is all about getting that app up and running. Or to be more precise, its main job is actually to show some user interface on the screen. And that in the end is a vital task for any app you're building. Now, as you can see in this code editor, I'm getting an error here, though. I do have this red squiggly line here, which indicates an error, a problem with the code. And if you hover over such an error, you get a more detailed description of what's the problem here. In this case, that a function body must be provided. Now, what's that? Now, in Dart, it's actually not allowed to run functions like this, just like that in the main.dart file. Instead, you must wrap instructions like this, code like this, into other functions. And for that, we must create a custom function, a custom instruction. And that's done like this. You type void, and I'll explain what this void thing means soon, but you type void, followed by the name of your custom command, of your custom function, which in this case should be main. It must be main, and I'll explain why it must be main in a second as well. Followed by parentheses and then opening and closing curly braces. That's how you define a custom function, a custom instruction, if you want to call it like this, in Dart. This here, main, is the so-called function name. This here is the so-called return type, and I'll get back to what that is soon. And then this part here, between the opening and closing curly braces, is the so-called function body. The code that should be executed when this function is executed. And that's another core programming and Dart concept. Functions, as mentioned, are in the end instructions, and you can create your own instructions as you see here. But those instructions, those functions, are not executed by the mobile device, by the computer on which the code runs, unless you tell that device, that computer, to run that instruction. And you do tell a computer to execute an instruction by using that instruction's name, followed by opening and closing parentheses. So in the end, what we're doing here in line 6, here we are executing a function. We're calling a function, as it's also called. Now, I did mention that run app is a function provided by Flutter, so not written by you, but provided by the Flutter framework. And since Flutter is an open source project, you can actually inspect its code. And attached you find a link to a file that includes this run app function definition, which is exactly that function that we're trying to call in our code, so that we're trying to execute in our code. And only if you use code like this, you are actually executing a function. So this main function, for example, is at the moment only being defined, but it's never executed because we never have code where we would call main like this. If we would call it like this, if we would add this piece of code, we would execute this function. That's why I also like to call functions code on demand. You define them, and then somewhere else in your code, you can use them as often as you want by calling them as I just explained it, by repeating that function name followed by opening and closing parentheses. And of course, it's not just you who can define functions, but also other developers, like the Flutter team did here with the run app function they defined for us as part of the Flutter framework. And this run app function must be executed, but as we saw in this error description, it must be executed inside of a function body. So we should actually move it into this main function body here, like this. In here, this function can now theoretically be executed, but now we're getting a new error. We're getting the error that the function run app isn't defined. So in the end, Visual Studio Code is telling us that it understands that we want to execute a function called run app, but it doesn't find this function anywhere. And where would it find it? In our code file, we only have the main function, nothing else. Where should run app come from? So the code editor doesn't find the run app function. It doesn't know where run app comes from. Now, of course, I showed you that run app is defined in the Flutter framework. It's coming from Flutter. But when writing code, you have to be very explicit. You have to tell your program that run app is coming from Flutter. It's not guessing that this could be the case. There are hundreds and thousands of libraries and packages out there in the world written by other developers, and therefore, of course, your code and your code editor doesn't guess from which of these many packages this run app function might be coming from. Instead, you have to tell your code. And for that, the first important step in a Dart program is to go to the pubspec.yaml file, because in that file you can manage the dependencies, the third-party dependencies of your project. You can reference other libraries or frameworks from which you want to use code in your project. And in there, under dependencies, you have to add all third-party packages which you want to use as dependencies in your code, so from which you want to use features. Now here, Flutter is actually already added as a dependency, so we don't need to change anything there, but it is important to understand that this entry must exist in order to use features from that package. Of course, here we're still getting an error despite having added this package in the pubspec.yaml file, and the reason for that is that even though we added this dependency, our code still doesn't magically look into those dependencies which we added and then check if there is some run app function anywhere in that third-party code. Instead, we have to add a so-called import statement at the top of the file. And we do this by using a special keyword, the import keyword, which is built into Dart. The import keyword tells Dart that we want to kind of connect our code file here, our main.dart code file here, with another code file. Or to be more precise, that we want to use certain features, certain functions, for example, that are defined in some other code file in this code file here. And for that, we have to add a so-called import path after the import keyword, where we specify from which file we want to import something. You define such a path by adding opening and closing quotes, double quotes or single quotes, that is up to you, but single quotes are more common in Dart projects. And then, since we want to import some code from a package here, we start by writing package, followed by a colon, and then followed by the package name. Now you see I'm getting some auto suggestions here by my code editor, which is a very useful feature because it can speed up development and it also reduces the danger of introducing typos, since we can use these suggestions to autocomplete our code, as I'll show you in a second. But here at the moment I don't have any suggestion that I need. Instead, I need some functionality from the Flutter package. Hence, after the colon we type Flutter, and you see that my suggestions are changing now. And then we want to get access to some code that's defined in some specific file in that Flutter package. And hence we create a path to that file by adding a /. And then for us, it's the material.dart file from which we want to get code. If I type MA here, the suggestions are narrowed down even more. And now, as I mentioned, it's this material.dart file I'm interested in. So we can select this with the arrow keys and hit Tab to autocomplete this path here. And that's the part that can speed up development and also avoid typos. Now we must end this with a semicolon, because basically all your statements must end with a semicolon. Function definitions are an exception. You don't add semicolons here after the opening or closing curly braces. But Visual Studio Code also tells us that this semicolon here is unexpected, so you can't really get this wrong. It also tells you if you forget a semicolon. Here, if I scroll down, The error messages are always at the bottom. I also get an error that a semicolon would have been expected. And with that, we have a valid import statement. And now the run app error went away. And you also might have noticed that the color changed from white, which is always a good indicator that some identifier wasn't found, to a light yellow color. I still have an error here, but that's now a different error, which we'll tackle next. But now run app is found because material.dart in the end gives us access to the run app function defined by Flutter in their code. And that, of course, was a lot of talking about this, but understanding functions, calling functions and function definitions, and how Flutter apps start is, of course, very important. So in the last lecture, we added this import path, and now this run app function is found, and we added it to this main function. But how exactly is this main function getting executed? If you paid close attention, you of course learned that functions can be defined, but then they also must be called, they must be executed in order to actually run the code that's in their definition. I mentioned before that if you just define a function and you never call it, the code inside of the function indeed also does not execute. And at the moment, main is never executed because we don't have this code here anywhere in the app. And indeed, you don't have to add this code, and you shouldn't add this code in line 7 to your app. Indeed, that's not required because the main function is actually a special function in Dart programs. That's also why these strange instructions above it were added automatically here in the code editor. Because the main function is the main entry point of a Dart app. To be precise, a main function in a main.dart file, and it will be executed automatically by Dart when your app becomes active on a device. So after your code has been parsed and compiled, when it then executes on a device, the compiled version of your main function gets executed automatically on that device by Dart. So you don't need to call main manually, instead it is executed for you. So that's something that's taken care of. And then inside of main, we of course call run app, because as mentioned before, that's another important step when it comes to activating a Flutter app or starting a Flutter app and drawing some user interface onto the screen, showing something on the screen. Because run app tells Flutter what to display on the screen, so which UI elements should be displayed on the screen. And that's now the last piece of code we must add to this code here to have a valid Flutter app that shows something on the screen. I'm getting an error at the moment that one positional argument is expected by run app, but that 0 arguments are found. And for that, of course, it's important to understand what arguments are, but also which kind of argument is expected here. So what are arguments? Well, functions can be defined like the main function to take no input values, but as you can see in the Flutter source code, they can also be defined such that they do expect some input values. And that's the part between those parentheses. Here you can specify a list of input values that are needed by the function to work correctly. Some functions don't need any input, like main, other functions do. And these input values are called parameters or arguments. Technically, they're called parameters when we talk about them when defining a function, and arguments when we talk about them when calling a function, but I will simply use these terms interchangeably in this course. So run app needs one argument, one input value to display something on the screen. And this should make a lot of sense because, like this, at the moment, how would run app know what to display on the screen? Well, the input value it needs is the content that should be shown on the screen. So the user interface it should show on the screen. And for that, run app needs a so-called widget or widget tree as a value. Because Flutter user interfaces are built with widgets. When building a Flutter app, you don't use some visual drag and drop editor. Instead, you build your user interface in code by using so-called widgets. You typically combine many widgets with each other. You nest those widgets into each other, as you will see over the next lectures, to build a user interface. And since you end up nesting widgets into each other, you will actually end up with a so-called widget tree, where you have some root widget at the top, then maybe a child widget with another child widget, which then may hold multiple child widgets, simply depending on which kind of user interface you're building. And of course, all these words here, all these widgets on this slide don't tell you anything just yet, but that will of course change over the next lectures and sections. So Flutter user interfaces are created by combining and nesting widgets, for example by adding a text widget, which is something Flutter gives you to display text on the screen, inside of a button widget to have a button with some text. And Flutter provides many built-in widgets which you can use in your code, like buttons, form inputs, layout widgets, but you can also build custom widgets. And of course we will also do that, actually quite a lot throughout this course as well. So Run App needs a widget or a combination of widget, a widget tree as I mentioned. So of course the question is, which widget and how do we add a widget in code? Now when it comes to the question which widget should be used, you can also search for Flutter Widget Catalog, and you'll find an official documentation page which gives you various widget categories which you can browse to learn about some of the most important widgets offered by Flutter. So the different building blocks you can use in your code. For example, to display images, to display text, and do many other things as well. Now, please don't go to this page and learn all these widgets by heart now. That's not how you will learn how to build Flutter apps. Instead, you will learn about all the important widgets step by step throughout the course, and you will see that in the end, you will always end up using the same 10 or 20 core widgets with some occasional niche widgets used for specific use cases. But you will learn how to use them, and you will learn which widgets are important simply by building apps and simply by following along with this course. Nonetheless, it's good to know that this page exists. And here, from this page, from the Flutter Widget Catalog, we have to use at least 2 core widgets offered by Flutter to have a basic user interface. And the first widget, which we want to use for that, which we therefore pass to Run App, is the Material App widget, written like this, capital M at the beginning and then capital A inside of the word. This is one of the widgets provided by Flutter, and we have access to it here because of this import. So the same package that in the end gave us access to Run App also gives us access to all these core widgets like Material App. Now you then use a widget in code, you create a widget, so to say, by adding opening and closing parentheses after the widget name. So Material App is the widget name, and this now creates the widget. Now this of course looks a bit like calling a function. It looks like what we did with Run App before, right? We also called that like this initially. Now here we're calling Material App. And to some extent it is like a function, but it's actually a so-called class or constructor function of a class to be precise. And I'll get back to classes and constructor functions later. For the moment, it's just important to realize that we can create a widget like this in our code. In this case, a built-in widget provided by Flutter. And Material App is a core widget which you will use in almost all Flutter apps you're going to build, because this is the main widget which you use as a starting point, so which you pass to Run App in the end, because this main widget does a lot of behind-the-scenes setup work for your user interface. So it ensures that the interface can be shown correctly on the screen. It does a lot of important behind-the-scenes configuration stuff. On its own, it doesn't show anything on the screen though. Instead, you need to pass another argument to Material App to show something on the screen. And that's now really important to understand. When calling Material App like this, we are creating such an app widget. So we're in the end telling Flutter to display this Material App widget on the screen, this part of the UI. So the Material App widget thing, whatever it may be, that is being created here is the value that's passed to Run App. So which is passed as a value to this parameter thing, this input value that is expected by Run App. And by the way, I will get back to what this widget thing here in front of this app parameter means in the near future. And that is something you'll see a lot in this course, and you'll do a lot in programming in general. When you define functions, so custom commands, or you're using functions defined by other people, like here, where run app is defined by the Flutter team, many of those functions will take input values to work correctly internally. Here, this app input value is used inside of that run app function thereafter. It's not important to understand what exactly happens with it here, but it is used internally. So being able to pass input values to functions so that those functions can then do something with those input values is a crucial part of programming in general. And here it's this material app widget thing that's passed as an input value to run app. Now, as mentioned, material app then also needs an input value though, because like this material app thing doesn't provide too much information to Flutter and to run app regarding what should be displayed on the screen. Instead, you must pass more information to material app so that that information will then indirectly also be picked up by Flutter. And for that, between those parentheses here, which belong to material app, you must provide some input value to material app. And that input value is now all about defining what should be shown inside of that app UI that will be displayed on the screen. And for this, material app also takes an input value, a parameter, though not a parameter that would be defined like this, as it's the case for run app, a so-called positional parameter, or positional argument, because here for run app, the first value you pass to run app is used as a value for the first parameter in this parameter list. And of course, run app only takes one parameter, but other functions could also take multiple comma-separated parameters, and then values would be passed in and matched by position. So the first value provided to a function when calling that function would be mapped to the first parameter, the second value to the second parameter, and so on. That's one way of accepting and receiving parameters in Dart. But an alternative way, which you will also learn in greater detail later, is to define functions that take so-called named parameters or named arguments. When defining the function, you wrap those parameters between curly braces, and again, that is also something you will learn about later in the course in greater detail, and which you will do a lot throughout the course. But in the code where you define a function, you would wrap those named parameters between curly braces. And the difference compared to positional parameters or arguments is that now it's not important in which order you pass values to the function when you call it. Instead, you identify those parameters by their name. And that's exactly how material app is implemented internally in the end. There you have a long list of named parameters, as you can tell by this opening curly brace and that closing curly brace thereafter, that wrap all those parameters. And those parameters are then simply identified by name. Now regarding super and this, these are all things we'll learn about throughout the course, but this material app thing which you can execute in the end is defined by using named arguments internally. And as a developer, it's up to you whether you want to use positional or named arguments when defining a function. When using it, you of course have to use what has been defined in there. And here for material app, it's this home named argument that has to be set to display something on the screen. And if you type here, you of course also get suggestions. Even without typing, if you press Ctrl space, you'll get a list of suggestions. And here you in the end see all these named arguments that you could possibly set, though many of them are of course for niche settings or configurations. The home named argument is important though, because that's the main argument you must set for material app to define which kind of widget, which kind of UI element should be displayed inside of that app UI that's passed to run app. And here I want to display some text by using the built-in text widget, which is written like this and which is also executed like a function. Just like material app, text is coming from Flutter and provided by the Flutter team. Now the text widget, if you hover over it, also actually takes some named parameters. You find a curly brace and a long list of parameters between those curly braces here as well. But there also is one positional parameter, and that's possible as well. You can mix and match those different parameter types as needed when defining functions. That is totally up to you, the developer. And here, this positional parameter is indeed what we must set when using text. Otherwise, we get an error that one positional argument is expected, but 0 arguments are found. And here, the one piece of data that we must pass in is some human readable text, which should be wrapped between single or double quotes, and single quotes are more common. And here you could write "Hello World," for example. Now these single or double quotes are required because without them, Dart would think that hello or world exclamation mark should be keywords or identifiers. Now hello and world are definitely not keywords built into Dart, so identifying these words as such fails. And they're also not valid identifiers because neither in the material Dart package which we're importing, nor in your file is there a hello or world function or anything else you could be referring to here. Referring to run app, material app, and text worked because those things are indeed defined here in material Dart. Hello and world are not defined there, and they shouldn't be, because here we're not trying to execute some commands or run some code. Instead, this should be human readable text, and whenever you have text that should not be interpreted as commands, you must wrap it with those quotes, so that this is marked as text that is, for example, meant to be read by humans and not executed as code. And with all those things, we now have our first basic combination of widgets where we create the text widget and pass it to the material app widget, which then in turn is passed to run app. And with that, if you now make sure that you have an emulator up and running and you start your application on that emulator, either by going to run without debugging, or by clicking this run button here, which is provided as a convenience by the code editor, by Visual Studio Code, you will see this Hello World text on this virtual device. It looks ugly, it's definitely not a good looking app, also not a useful app, but it is a first step and it's our first user interface built with Flutter and widgets that's shown on the screen. Now we can dive in deeper. So we got our first screen output, our first basic UI, even though it's of course neither helpful nor pretty, but it's a start. We achieved this by combining the material app and text widgets and passing that widget combination in the end to material app. Now you might notice that there are some blue squiggly lines below that code. Now in Visual Studio Code, blue squiggly lines, as we have them here, mean that there isn't an error, but there is some improvement potential. The code is not optimal or it does something that should be changed. And you can hover over the code that has these squiggly lines to learn more about the problem. And if you scroll down in that info box, because the messages are always at the bottom, you see that here the recommendation is that we should use const with the constructor to improve performance. Whatever const is. Well, we can get rid of these blue squiggly lines by adding const in front of material app. But what is this const thing? Well, const is a keyword, as you can also tell by its color. It has the same color as void and import. So it's a keyword provided by Dart, built into the Dart language. And const is a keyword and a feature that exists to help Dart optimize the runtime performance of your application. And how does it do that? Well, if you mark something as const, let's say a text widget that you're using in your app, then this text widget will be stored internally in the memory of the device on which the app runs. And that will always be the case, no matter if you use const or not. Once your code executes, the things that are created by your code, the widgets for example, will be stored in the device memory. But with const, when you then use that same widget with the same text a second time in the app, that existing memory thing will be reused instead of a second memory object being created. So therefore, using const allows Dart to reuse values that are indeed equal and avoids the duplication of data in memory, hence making your app more memory efficient and improving overall performance. Of course, behind the scenes, things are a bit more complex, but that is in a nutshell what's happening. And that's why you should always add const when prompted for it. Now, the good thing is, you don't need to learn by heart in front of which widgets you should add const, for example. Instead, your code editor will simply tell you by adding these blue squiggly lines here. And then you should indeed add const. Of course, for this basic app, it doesn't really make a difference. We're not reusing this combination of widgets anywhere, so marking it as const won't give us any big advantages here, but it also doesn't hurt, and it's simply a best practice to use const in front of all the values where you can use it. And as you saw, using it in the right places is very simple because your code editor simply tells you. It, for example, also tells you if you're using it in a place where you should remove it. For example, here, if I add it in front of material app and in front of text, then I get a message here that I'm using const unnecessarily in this place because I'm already using it in front of material app, which then contains text. So using it in front of text in addition to that is simply redundant and therefore should be removed. But that's in the end what const does. It allows Dart to run your application in a more efficient way. Now, of course, this is ugly as mentioned, so how could we make it more beautiful? Well, to make it more beautiful, we have to add more widgets. At the moment, we only have a very basic combination of widgets. One widget that will help us a lot with making this look better is another built-in widget, the scaffold widget. Now, you can always, of course, read about widgets in the official documentation, and there you also learn how to use a widget. But you're watching this course so that you don't have to do that, though that of course is always a great backup resource. But the scaffold widget is a widget that in the end helps us with setting up a good looking screen in our app. The material app widget is the root widget, which is important for setting up the overall app. But many apps of course consist of multiple screens, and those screens also must be set up. And even if you have just one screen in the app, as we have it here, this screen must be set up to have, for example, a nice background color, to enforce some basic styling onto its child widgets, and so on. So therefore here, we want to wrap text with the scaffold widget, because scaffold must be inside of material app, but should be wrapped around the widgets that belong to a screen. Now to wrap text with scaffold, we can of course type scaffold here and execute this. And then grab text here, this text widget, with its text content, and then pass it to scaffold, though scaffold now again wants a named argument. And in case you're wondering how I know which widget wants which kind of arguments, you can hover over a widget to learn about the accepted arguments here in this info window that opens up. You can also learn about supported arguments here in the official documentation, but of course for the moment I will simply tell you which arguments can be passed where, and you will then automatically memorize these things as you gain more experience with Flutter. So for scaffold, it's actually a body argument which we should set here, and I'm also getting some auto-completion here whilst typing this, which of course helps a lot. And the value for body then is the widget that should be shown inside of this scaffold widget. So with that, if I save this should reload automatically. If it doesn't, you can press this refresh button here in this panel, which opened up when you started the app, and now it should update. And you see it looks much better. We got the white background, the hello world text looks nicer, even though it's still, of course, hidden in the top left corner, but we already gained a lot by adding this widget. It's of course not enough though. Instead, it would be nice if Hello World would be kind of in the middle here, if it would be centered on the screen. And that can be achieved with help of another widget, which of course also can be found in the widget catalog in the layout category, since I want to center my text here, so it's a layouting action I want to perform. And there it's the center widget that can help us with, well, centering widgets. For that, we need to wrap text with yet another widget. And that is something you'll do a lot when writing Flutter code. You'll build these complex widget trees, as I called them before, where you have widgets inside of widgets inside of widgets. So here we want to wrap text with yet another widget. And for that, we could manually add it as before. But you can also right-click on code here on this text widget, and then choose this refactor action that's suggested by Visual Studio Code. You can, of course, also use the shortcut that's suggested for that. And if you click that, you get some refactoring suggestions. And refactoring in programming simply is the process of changing your existing code. And here you get some smart actions suggested. For example, you can choose wrap with widget to get some help with wrapping this with a widget. But you even get a wrap with center suggestion here, which you can pick by clicking on it or by selecting it and hitting enter. And this will automatically create the center widget and pass the text widget to center, to be precise, to the named child argument of the center widget. Now, of course, things are getting quite unreadable here. This is becoming a super long line here, and this is still a simple widget tree. And therefore, of course, you typically want to structure this code a bit differently to make it easier to read and to maintain. Because even this basic widget combination is already getting too long here. Now, to make this easier to read and more structured, Dart offers a nice trick, or actually recommended pattern or approach to help with formatting widget trees. For that, you should add a comma after every closing parentheses here, except for the last one, where you need a semicolon. And if you do that, you can run the format document command in Visual Studio Code, or use the shortcut for that to auto-format your code, which is something I do a lot when writing code in general. And if you hit this shortcut, you see the code changes, it's formatted differently, and now it's way easier to understand this widget tree. Because now you have some nice indentation that shows you which widget is inside of which other widget. And this widget tree, this code, is now way easier to read and understand. And this is something you can do in many programming languages, definitely in Dart. As you can see, you can split code across multiple lines. And you then don't have semicolons at the end of those lines, because this in the end here is still one single instruction, just split across multiple lines. Now, you can't split it at arbitrary points, for example, not in the middle of a word, in the middle of material app, that would fail, but you can split it here after these opening parentheses, for example, and also after such a closing parenthesis and such a comma here, or even in front of the comma if you wanted to, but this auto-formatting shortcut will basically do that for you. And by simply adding these commas after all these closing parentheses, you're giving the code editor in the end a signal where to best split this code when using this auto-formatting shortcut, because it will then simply do this after every comma here. And since you will build a lot of widget trees when building Flutter apps, and of course also way more complex widget trees with way more widgets than we have it here, it is absolutely a recommended pattern to always add these commas after your closing parentheses, and then use this auto-formatting shortcut to make sure your code is structured and easy to read and understand. And if you save this now, it again should update automatically, or if it doesn't, as it's the case for me, update it manually. And now you see that Hello World is centered in the middle of this screen. So by adding these two built-in widgets, Scaffold and Center, we again improved the app, and we're making good progress towards our goal of building our first custom Flutter app. So we built our first basic widget app that leads to this user interface. And before we'll dive deeper into that and make it a bit more pretty and of course work towards our final application goal for this section, I want to dive into another crucial Dart feature, which is extremely important and which you must understand in order to work with Flutter and Dart. Because of course, this section is not about building the final app as quickly as possible, but about learning all these important Flutter and Dart fundamentals. And one important fundamental Dart concept that you must understand is the concept of types, because Dart is a so-called type-safe language, which in the end means that all values you're working with are of certain types. For example, this hello world text is a so-called string. If we had a number like 29 in our code, it would be of type int. Material app is of type material app. And actually, there's not just one type per value, but instead values are typically of multiple types. For example, this hello world text is not just of type string, but also of type object. The number is not just of type int, but also of type num and of type object. And material app, for example, would be of type material app, but also widget and also object. So values can be of multiple types. As you see, for example, all values are at least of type object, and then they also have more specific types. And I'll get back to objects and what's that all about a little bit later. And those types are either built into Dart or provided by a third-party package or provided by you when creating your own types, which you typically do implicitly. And in our application here, we're also working with types in a lot of different places. But why does this type feature even exist? Why does it matter that this text is technically of type string? Which you, by the way, can also see if you hover over it, because then the code editor shows you some information about the thing you hovered over, and that always also includes the type of that value. For example, here string. For a material app, it's a bit harder to see, but here the type annotation would be this thing in front of this material app function argument information. But why does this type feature exist? It exists and it's enforced by Dart to make sure that you're never accidentally using the wrong type in the wrong place. For example, you might want to display a number on the screen, and therefore you could replace hello world with that number. But you would see that here in my code editor, I'm now getting an error. When I hover over this, I learn that here in the end, I can't provide a value of type int, which is that number type, which you just saw a couple of seconds ago on the slide, to a parameter that actually wants a string, so that wants some text. Put in other terms, the text widget internally, as it was defined by the Flutter team, only knows how to work with string input values, with text input values. It does not know how to work with numbers. Of course, you could argue that displaying a number on the screen should be possible, and it is if you convert this to a string by wrapping it with quotes, which in the end is what those quotes really do. They create a so-called string, text. But of course, numbers are a special case. What if I would pass a material app widget here? Now it might make more sense that text can't output this, because how should this material app widget, which is all about creating the frame for an application user interface, how should that be output on the screen, right? How should that be treated as text? And to make sure that the text widget doesn't have to guess what it should do with its input values and how it should output those values as text, the Flutter team built the text widget simply such that it only accepts text, that it only accepts strings to be precise. And you can also see that if you hover over it to get more information about it, here you see that first argument, the only positional argument, positional parameter wanted by the text widget, which is that parameter we're setting with that first value we're passing between those parentheses. And here you see this annotation in front of data. Data is simply the parameter name, but the annotation in front of it is the type that's expected for this parameter. And if you would create a custom function, which you want to use somewhere else in your application, you could also add such type annotations to make sure that you, for example, only accept numbers, so-called integers, if you use the int value here. So that, for example, if you would pass some text here to this function, you would get an error because your function might not know what to do with text. It wants numbers, to add them as numbers, not to combine them as text. That's why this type feature exists. It's there to ensure that you as a developer can be clear about which kind of values you want to accept and which kind of values you don't want to accept. For example, the runApp function, which we're using in our code, wants a widget as its first and only argument. So a value of type widget. And it turns out that material app, which is in the end the value we are passing to runApp, is such a widget. And here for the text widget, we should of course go back to a real text. So that's the idea behind types. And in Dart, types are everywhere, not just in the parameter lists of functions. For example, this thing in front of main, this void thing, is also a type. It's the so-called return value type of the main function, but that is something we'll get back to later in the course once we actually have functions that do return something. Now, as mentioned, you can build your own types, and you also get many types by third-party packages, but Dart also ships with many built-in core types. Of course, you might not understand all of them just yet. You will see all of those and many more in action throughout this course, though. For the moment, the most important takeaway is that this types feature exists so that you can't work with the wrong types in the wrong places. So now that we know about types, it's time to come back to our application code here and continue working on this application. And I would say one next step that makes a lot of sense is to make this look a bit nicer here, because to be honest, right now this application is really boring. And for that, I'd like to change the background color from white to a nice gradient, and also change how this text here looks like, so that it looks a bit nicer, a bit more fancy. Now let's start with the background color. For this, we can go to this scaffold widget, and besides setting the body argument there to the widget that should be displayed inside of the scaffold, we can also set one of the many other arguments supported by scaffold. Because most widgets allow you to pass values to different arguments. You almost always have at least one argument, like body or child, that wants another widget, which then is included in the wrapping widget, in the outer widget. But you also often have other arguments that don't want widgets, but that instead allow you to configure and or style this widget. And for example, scaffold, if you add a new line in there and press Ctrl space, supports a broad variety of arguments, for example, the background color argument. And as you might guess, the background color argument allows you to set the background color of this screen that's created by scaffold. Now, background color wants a value of type color. Now that you learn about types, you know that that thing in front of the parameter name is the type definition. And this wants a color, or actually it wants a color question mark? Well, this question mark simply means that we can either set a value of type color or nothing, so that this may be null, as it's called. We can set this to null, which is a special kind of value and type supported by Dart, which in this case is pretty much the same as not setting background color at all. But if we do want to set it to some non-null value, so to a value that has some visual effect, it must be a value of type color. Now, such a color value can be created with the built-in color class or constructor function. Now, keep in mind that I mentioned before that material apps, scaffold, center, and text are of course widgets, but that technically what we're calling here, like functions in our code, are so-called constructor functions. And I'll get back to the concept of constructor function and related to that classes a little bit later. Here we can use the color constructor function to create a color thing. Though if you're just getting started with colors in Flutter projects, it's typically easier to use the special colors thing, and then there you don't add parentheses, but instead you use a dot to access a list of predefined colors. And here you see a long list of predefined colors which you can use, like for example deep purple, like that. And if you save that and force a reload, you will see that color here as a background for this screen. And this already looks nicer than the white background we had before, at least in my opinion, but it's not the final styling I want to have here. But what is this thing here now? Well, if you hover over Deep Purple, you for one get a color picker, which you could use to pick a color more conveniently, which is pretty nice. You will see that if you do that though, it changes from colors dot something to color dot and then some function that's being executed here to which some values are passed. In the end, this here is a function provided by this color thing here, which is provided by Flutter in the end, which simply allows you to create a color by mixing red, green, and blue colors and an alpha channel that controls the transparency of the color. So that's simply a way of creating a color by mixing 3 different colors, though of course the easiest way of using this and doing this is to use this color picker, which opens here in Visual Studio Code if you hover over it. But of course that doesn't answer the question what this here is in the end. Well, if you scroll down from that color picker, you in the end see that this from ARGB function here, which it is, gives you a value of type color. Which makes sense because background color wanted a value of type color, of course. So we got another type here, not a type built into Dart, but instead a type provided by Flutter. And what this in the end is, like all values, as you learned before, is an object. Widgets in Flutter are also just objects in the end. They are objects, and objects are the base value in Dart. All other values are also objects in the end, and objects are simply data structures in memory. So that's simply how Dart saves your values in memory on the device on which your application is running. Now, objects are a core concept in Dart because, as mentioned, all your values are objects in the end. And there are simpler objects like this text, this hello world text, but also more complex objects like this color object or your widget objects like material app or scaffold. But in the end, all these are simply data structures in memory that are managed by Dart, and these data structures can also work together. And for example, background color wants a color object so that behind the scenes the scaffold widget object is able to reach out to that color object and use that color information that's stored in that color object to make the background color of this user interface purple. So it's all objects. Widgets are also just objects, just special kinds of objects in the world of Flutter, if you want to call it like this. But all these objects are working together to bring the final user interface onto the screen. And I'm really emphasizing this because when building apps with Flutter, you will always have many objects work together. You, for example, have widgets that are nested inside of other widgets, but you also have configuration objects like this color object, which then, for example, could be used by your widgets. And that's how we could add a background color, though it's of course not the final background color I want to have here. But using this helped us get started and become aware of the important concept of objects in Dart applications. So knowing about this objects concept is crucial because all values are objects in the end, as you learned. But here my goal is not to set this just to some purple background color. Instead, I wanted to have a nice gradient. Now this can't be achieved with background color because that wants a single color. And scaffold also has no other argument that we could set that would allow us to add a gradient background. Instead, what we can do here is we can add another new widget between scaffold and center so that it wraps center and therefore implicitly also text by right-clicking on center and refactoring this. And here we want to wrap this with a container, which is another widget provided by Flutter. And container is a widget that's very useful for configuring styling and layout settings. Now here, after adding container, I get some red squiggly lines. And if we hover over that, we learn that we should remove const, because that seems to be responsible for these red squiggly lines. And indeed, if you remove const here in front of material app, they go away. And you can now re-add const in front of center. Container is simply a widget provided by Flutter that doesn't support setting it to const. And therefore you also can't set some parent widget that's higher up in this widget tree to const. It is what it is, but your IDE clearly tells you where you can and can't add const, so that's pretty good. But of course we got more blue squiggly lines here now, but the reason for that simply is that at the moment Dart and our code editor thinks that we're unnecessarily using container. And we do. If we don't configure anything, it's a useless wrapper, because if you save this and you reload, you will see that nothing changes about the app, except for the background color, since I removed the background color on scaffold, but nothing else changes. But of course our plan is not to do nothing here. Instead, container now also gives you many useful arguments that you can set. For example, it provides a decoration argument. And this allows you to add various kinds of, well, decoration to the container, and therefore also to the child elements inside of that container. Now decoration wants a decoration argument, so an argument of type decoration, and such a value can be created, for example, with the built-in box decoration constructor function. There actually also is a decoration option here in this suggestions menu, but this is actually not the right thing to use here. Indeed, you can't use it if you try to use it, because it's a so-called abstract class, and we'll learn more about classes later. For the moment, it's enough to know that you can't use that, but you can use this box decoration constructor function, and this will then also give you such a decoration object. Of course, it will give you a box decoration object, but as you learned, values can be of multiple types, and box decoration objects are also of type decoration. Just as material app is not just of type material app, but also of type widget. This might all sound confusing, but you're just learning it here. You're just getting started with it. You will get a lot of experience with that over time as you're using all these features. Now, this box decoration constructor function, which we're calling here, to build such a box decoration object, then also supports various arguments that can be set. For example, the gradient argument, which sounds just about right for what we're planning to do, because our goal is to add a gradient here. So the gradient argument can be set here, and that then wants a value of type gradient. Now there are different ways of creating gradients, for example a radial gradient, or what I want to do here, a linear gradient. This is another constructor function that creates a linear gradient, which is also of type gradient, and which therefore is a value we can set for this gradient argument. And this linear gradient constructor function wants even more arguments. And what we're doing here is quite typical for Flutter development. You often end up nesting widgets and/or configuration objects into each other so that they can work together and give you the overall desired user interface. Don't forget to add those commas after all the closing parentheses to make sure that your code is styled in a readable way so that you never lose track of how these things are related. And here for a linear gradient, there are again more things we can set. Most importantly, this colors thing here, this colors argument. And this colors argument now wants a special kind of value. So which kind of value does this colors argument want here? Well, if you hover over it, you see that it wants a list, and then we have these angle brackets and color between them. What does this mean? Well, for one, it means that it wants a list of values. Not just a single value, but multiple values. That is what a list is in Dart, a collection of multiple values. And that makes sense because we want to build a gradient here, so a transition from one color to another color or between multiple colors potentially. And therefore it makes sense that it's not enough to provide a single color. So that's why we need to provide a list. Now these angle brackets which you see here in the type definition for this colors argument are some special Dart syntax which creates a so-called generic type. This is also something we'll see in greater detail throughout the course, But in the end, a generic type is simply a type that needs to work together with other types, but is flexible regarding which exact types can be provided. For example, list is a type built into Dart that's quite flexible. Depending on your use case, you can have lists of numbers, of strings, of other objects, whatever you need. And when defining the type for a list, it's simply the type between the angled brackets that defines which types of values may be in that list. And here we want a list full of color objects. That's what this type says. So therefore here we now can pass such a list of colors, and a list value is created in Dart by using square brackets, opening and closing. And between those square brackets, you can now add all your values. Now, for example, your strings. But of course, here we don't want strings, we want colors. So we can create them with the color function, or with color from argb, or with the colors object, which simply gives us some predefined colors to choose from. So for example, again, deep purple here. Though here I actually don't want that, instead I'll use the color picker again to select a nice dark purple, and you can of course choose any color of your choice. And then in this list we can add a comma to add a second value to that list, because in lists values must be comma separated. We can copy the first color as a second value in that list, and then pick a slightly different color, maybe more purplish, a little bit lighter, whatever you want. I'll pick this color and also add a comma after the closing square brackets. That's another place where you should add commas for proper code formatting. And if I now auto format this, that's a bit more readable, though it would also be nice to get rid of these blue squiggly lines. And here, if you hover over them and you scroll down from that color picker, you in the end see that it's about const again. And we want to add const at the highest possible place, which in this case is in front of box decoration. So in the end, these are all, again, objects that support being set to const, so that Dart can possibly cache, store these values, and reuse them if we would use them somewhere else in our code to take advantage of this memory usage optimization and potentially improve our application performance. And with all of that, we're using a bunch of objects in conjunction, and we learned about this special new list value type, which is a generic type that is able to work together with other value types, though here it's really a list of colors that's needed. And with all that, if you save that and make sure that these changes get applied, you see this gradient in the background. And of course, you can pick colors with a greater contrast to see this gradient a bit better, but here I have just that slight gradient, which is exactly what I want. So we added this gradient. I'm not totally happy with it yet though. I'm quite content with the colors, but by default that gradient goes from left to right. Now I'd like to have it go from the top left to the bottom right. And this is something that can be changed by adding more arguments to linear gradient. Besides setting the colors here, you can also set the begin and end settings, amongst other settings, with which you can of course also play around. Now begin wants a value of type alignment geometry, which can conveniently be set with help of the alignment object here. Now you can set this to x and y coordinates, or you don't use the parentheses here, but instead the dot notation here to access some predefined values again. And here you have many predefined values like center, center left, and so on. And you, for example, also have top left, which is where I want my gradient to begin. And I'll set the end argument to alignment bottom right. Also add a comma here for proper code formatting. With that, if we save this and make sure this is applied, the gradient now indeed goes from top left to bottom right. And in case you're wondering how I always know how to create the values that are wanted by end and begin, for example, so how I, for example, know about this alignment thing here with those predefined values, there are a couple of ways of finding out. For one, of course, you learn it in this course, and you will learn about many common, super important widgets and configuration objects and options throughout this course. So that's a great start. But in addition, if you must provide a value and you have no value yet, you can also always press Ctrl Space to get some suggestions. And typically the first or second or third suggestion is already a suggestion that helps you, because this suggestion menu here is pretty smart. And here for setting the alignment, it even shows me these predefined alignments I could choose, like for example bottom right. So that's pretty good. But of course you can also always dive into the official documentation. For example, for searching for Flutter and then the name of the widget you're using. This will lead you to an article in the official documentation, and there you can also learn more about using this widget or this configuration object or whatever you have here. And you also often find some examples here, or a more detailed description of the constructor and the alignment geometry object. And then here, for example, you would get some hint about using the alignment thing, which we did actually use. So that's how you can learn more about this. But again, you will see many common widgets and configuration objects and options throughout this course. So now that we get started with some styling options, I also want to style this text. And to be precise, I want to make sure that this text is white and maybe has a slightly bigger font size. Of course, we're soon going to get rid of the text anyways, but as a practice, let's see how we could style it. And even though it will be a challenging practice, you also might want to try this on your own. See if you can find out how to change the text color and font size of this text on your own. Just as a hint, you won't need to wrap any widget around it. Now here's a short pause for you to pause the video and see if you can do this on your own. If not, no problem. After a few seconds, we'll implement it together. So, did you find a way of changing the color and font size? If not, no problem. This was challenging and we're just getting started here. If you want to style this text, as mentioned, you don't need to wrap any extra widget. Instead, you just have to add some extra configuration via some arguments. So by adding a comma and then adding more arguments to this text widget constructor function here. And that's, by the way, always a good way to start. If you want to style something or change some configuration of some widget, the first step should always be to see if there are some arguments that you can set that might help you. For example, here, if I open this suggestion menu after typing this comma and hitting Ctrl Space, I see that there is this style argument I can set, which sounds like exactly what we need here. And then, as a next step, I get the suggestion here to add such a text style object, as it turns out, with help of the text style constructor function. And this also sounds like a good idea. So I'll take this, add a comma for formatting, and then text style takes more arguments. For example, a color argument, which seems to set the text color, since there also would be a separate background color option. So I'll choose color here, and color then wants a color object again. And we of course already learned about that. We can create a color manually, for example with this from ARGB function, or we use a built-in one via the colors object here and the dot notation, and here it's white which I want. So that should set the text color to white. And regarding the text size, the font size, there conveniently is a font size argument I can set. And this wants a value of type double, and you learned a bit earlier that this is in the end a number with a decimal place. So here I can set this to 28 for example, and you can even omit the decimal place, though you can also set it. For example, also to set this to 28.5. But here I'll set it to just 28, add another comma for formatting, and if I now save this and reload, I should have a white text that is a little bit bigger. And that indeed is the case. And that's the practice solved. That's how you can style text. Something we'll do again and again throughout the course, because text often needs to be styled in a certain way. But that's there for it for the moment. Now it's time to dive into building custom widgets. So by now, at this point, our application is slowly but steadily taking shape, and it definitely looks way better than it did at the beginning, but our code grew quite a bit. Now, of course, that's still not too bad. That's absolutely fine. I'm also zoomed in quite a bit here to make this all as readable as possible for you. I can, of course, zoom out to make sure that I really see all the code I want to see. But still, this widget tree with all its extra configuration items is growing, and therefore what you typically want to do as you build Flutter apps is you want to break those big widget trees apart and build your own widgets, which you can then use to split your code into multiple smaller, potentially reusable building blocks, so that you can build your own widgets by combining other widgets with each other. And that's exactly what we're going to do now. And in general, when it comes to breaking up a widget tree and extracting custom widgets, there isn't a single right or wrong way of doing this. It's up to you which widgets you want to put into a custom widget. But here in this demo application, I would say that it could make a lot of sense to take this container with all its settings and all its child widgets, so this entire selected part, and put that into a separate widget. Because that would then allow us to use this container that has a background gradient applied to it in other places of our application. Which could be a good idea, because then we would have that reusable pre-built container. Of course, in this application, this is the only place where we are using it, but in more complex, bigger applications that might potentially have multiple screens, it's quite likely that you want to reuse certain widgets across different screens or in different parts of the app. And even if you're not reusing something, breaking up this widget tree and putting this container into a separate widget can still help us with overall code readability and code maintainability. So how do we put this into a separate widget then? Well, for that we must create a so-called class by using Dart's built-in class keyword. But what is a class now? As you learned, widgets are objects, and objects are simply these data structures in memory. And of course, not just widgets are objects. As you learned before, all value types in the end are also objects. So all value types are such data structures in memory, and that's why this objects concept is a key concept in Dart. Now, classes are closely related to this objects concept. For that, it's important to understand that Dart is in the end an object-oriented language because, as mentioned, every value is an object. And of course, you have such primitive values like text or numbers, which are created by, for example, wrapping text with single or double quotes or simply writing down a number in your code. But you also have more complex values in your code, like, for example, these widgets, but also these configuration objects which you saw. For example, the object that allowed us to configure our gradient, or the individual color objects. And those more complex values are created with help of classes, because classes in Dart and in many other programming languages as well are simply the blueprints for objects. Now, why do we need such blueprints, though? Well, as mentioned, objects are these data structures in memory. And here a good question would be, what's inside these data structures? And the answer is data, so-called variables or properties. For example, the username of a logged-in user or the color you chose for a gradient. But also logic, functions, or as it's typically called in the context of objects, so-called methods. So objects in the end are really all about organizing data and separating logic, so that logic that works with certain data is typically in the same object as that data and not in some other object or some other place in your code. For example, this color object here will contain the different color values for its red, green, and blue colors. And if you add a dot thereafter, which is the Dart syntax for accessing data or functions that are grouped into an object. If you type such a dot, you get a list of different variables, properties that you can access. So the data I just mentioned that would be stored in the object, the red, green, and blue color values, and some other pieces of data as well. But you, for example, also get some functions down there with blue, with green, that, for example, would allow you to create another color based on this color. And which functions are provided by which object simply depends on the definition of this object. And that's now where these classes become important, because with those classes, you define exactly that. You define which kind of data will be stored in an object when it is then created at runtime, and you define which extra functions, so-called methods, might be stored in such an object. So color here, like container and scaffold and box decoration, all these things are in the end classes, or when executed like this, or when using this from argb function here, you are in the end using so-called class constructor functions, which simply are functions that are used to create objects based on those classes. But all these things have classes as blueprints, as you can also see in the official documentation. This is the linear gradient class after all, as you can see here. And you see more classes that are related on the left. So these are all the blueprints that are built into Flutter that you can use in your code to create objects based on those blueprints. So in your code, you in the end work with the classes and their constructor functions. And when your application then runs on a device and your code executes from top to bottom, then the actual objects are created and stored in memory. That's how you can think about that. So all these built-in widgets, like these configuration objects here, in the end are classes, which you then turn into objects by executing them like functions, so by calling their constructor functions. This process is also called class instantiation or object instantiation. You are instantiating a class. You are creating an object based on a class. And that's why your custom widgets are also classes. The built-in widgets are defined as classes. You define your custom widgets also as classes. So now that we know that it's all about objects and that those objects are built based on classes, the question is, which code do we have to write here to create our own widget class? And the answer to that is that you use the class keyword to tell Dart that you are about to create a class. And then any name of your choice, like gradient container. The name is up to you, but it should follow certain rules. For example, it should start with an uppercase character. And if it consists of multiple words, as this name here does, these words must not be separated by white space or a dash, but instead you should separate them with an underscore, or way better and actually recommended like this. It's all one long word, but the words inside of the word start with another capital character. So that's then the name of your class, and as mentioned, it is up to you. It should just follow some general rules regarding how the name is written, and it should also describe what the class is about, so which kind of object will be created. And here my idea is to create a container widget that will come with a gradient already applied to it. So that name sounds quite fitting. Now you could create a class like this, because in Dart you can also create classes that are not widgets, and in that case you would probably be done at that case. You could add curly braces and add your class logic between those curly braces, just as you add function logic between the curly braces of a custom function. But since this should become a widget, you actually have to add more in front of these curly braces. Because classes can extend other classes. They can inherit features and data and logic from other classes. And that's done by adding the extends keyword, another keyword built into Dart, and then the name of the class from which you want to inherit. And here that's stateless widget, written like this, which is a class that comes from the Flutter framework, and that is available here because of this import which we added at the top at the beginning of this section. So stateless widget is the class from which you want to inherit, and inheriting from that widget does a couple of things. Most importantly, it automatically, behind the scenes, adds a lot of logic and data to this class here without you writing anything between these curly braces. It adds a lot of data and logic that is required by Flutter in order to use this as a widget and add this to a UI. But in addition to adding things behind the scenes, extending from stateless widget actually also forces you to add something to your class. And that's why I'm getting an error here at the moment. Because at the moment I'm not implementing everything in my own class that I should implement. Most importantly, I'm missing a method called build. So therefore, to correctly extend this widget, you should add a new method here called build with parentheses and opening and closing curly braces. So just as you would define a function, but now inside of a class. And you can add functions to classes. We then call these functions typically methods, but it's in the end just a function added to a class, so in the end bound to that class. And this build method here must return a widget. Therefore, you have to add widget in front of build, because as I mentioned earlier already, the thing in front of your function name is the return value type of your function. Now, thus far, we haven't created any functions yet that would return anything, but that's going to change soon. Now, you also should add an annotation in front of your build method, and that's @override. This is technically not required, but you should indeed add it because this makes it clear that you are in the end overriding a method that is expected by stateless widget. It's simply some extra metadata or annotation added to this method. The more important adjustment that also must be made in addition to adding the type and @override is that build also must accept a parameter. A parameter which you should call context or CTX, though the exact name is up to you. But this is required because indeed this build method will be executed for you by Flutter. Flutter will call this build method once it finds your widget inside of some other widget or passed to the run app function. So basically, whenever Flutter detects your widget in a widget tree, it will call this build method. And this build method will then automatically receive by Flutter a value for this context parameter. Now, for the moment, this context parameter doesn't matter. You will see it in action later in this course instead. For the moment, you can simply think of context as a metadata object that contains some useful information about this widget in the overall widget tree. For example, some information about where this widget is positioned in the overall widget tree. Now, between those build method curly braces, you now have to add the body of this function. And here you have to do one important thing. You must return a widget, because widget is the return type of build. Now, up to this point, in all the examples I just showed you from time to time, you always saw void. That's of course also what we have in front of the main function. And void is also the return value of a function, but void is a special value built into Dart, which simply means there is nothing to be returned. So the function should not return any value. And for build, that's different. Build should return a widget. Now, how do you return a value in Dart? Well, inside of the function or method that should return a value, you use the return keyword. And then thereafter the value you want to return. And when a function or method returns a value with that return keyword, that value will be available in the place where the function was called, and it can then be used there. Now, in case of the build method, as mentioned before, it will be Flutter that calls this method for you behind the scenes when it renders the user interface. And Flutter will then take the widget returned by build and make sure that it's reflected on the user interface. So by using return here in this build method, you ensure that Flutter gets access to the widget or to the combination of widgets you want to store in your own custom widget here, because custom widgets in the end are all about storing combinations of other widgets and configurations. So here in this build method, you return the value that will be used by Flutter. For example, some text. Though of course here it's not some text that's wanted, but a widget. And therefore here, instead of returning text, we now go to our main widget tree and select the part of that tree that we want to outsource. In my case, the container widget with all its configuration and child widgets. And we cut that from here and return that in our own widget instead, in the build method after the return keyword. Like this. Container, in the end, is of type widget, and therefore now here Dart is happy because build does return a widget. So that's the first step. I got some blue squiggly lines here. For the moment, we'll ignore them. I'll get back to that soon, but that's the first step. As the next step, we can now use our own custom widget here in our main widget tree, which we pass to run app. And for that, we simply use our widget with its name, in my case gradient container, and add parentheses thereafter. And this calls the constructor function of this class, which in this case is not a function we added explicitly. I'll come back to constructor functions in just a second, but instead for the moment we just call a constructor function that's automatically added to all classes. So even if you don't add your own constructor function explicitly, which you can do, but which we're not doing here, you get one automatically by Dart. And with that, if we save everything and force a reload, this app looks the way it did before, because of course we haven't added any new UI elements, but the fact that it looks like before and we don't have an error here shows us that outsourcing this code into a custom widget worked. And this was a crucial step because you will work with custom widgets all the time when working with Dart and Flutter. You will see it all the time in this course, and you will need this feature all the time in your own projects. So we added our own custom widget. Now before we continue, there are two things I want to do with that. For one, we got these blue squiggly lines. And the question is, where's that coming from? Well, if we hover over it, we see that constructors for public widgets should have a named key parameter. So what's that about? In the end, your own widget classes, so classes that extend stateless widget or some other class, which you'll see later, should have a constructor function added to them. I mentioned that typically you don't need to add one, you get one automatically, but if you want to add some extra settings or some extra configuration at the point of time this widget is created, you have to add your own constructor function. And adding a constructor function is quite straightforward. You simply repeat the name of your class, so in my case gradient container, and add opening and closing parentheses thereafter. Now you could add opening and closing curly braces, so you add this like a method just without a return value, but other than that you add it like a method. And then here you could do some initialization work. This, by the way, is a comment which can be added with 2 forward slashes and which allows you to add some comment text which will not be interpreted as code, but which will be ignored, but which can help other developers understand your code. So this is how you could add a constructor and do some initialization work, though often you won't even need to add these curly braces. Instead here, to get rid of these blue squiggly lines, you just have to accept a special named parameter as part of your gradient container. And you do that by adding opening and closing curly braces. This is how, in any function, you can accept named arguments. Positional arguments are accepted by simply adding a comma-separated list of parameters. Named arguments or parameters are accepted by using curly braces around that list. And then here, for example, A and B would be the names of the arguments you want to accept. But here it's a special argument named key which you should accept. And this key argument in the end needs to be forwarded to stateless widget. So this widget from which we are inheriting, which we are extending, wants a key argument. And that's why your class should accept such a key argument as well and forward it to stateless widget. Now to forward it, you have two main options. You can add a colon after your constructor function name and the parentheses. And then thereafter, you can do some variable initialization work, which sounds strange, also because we haven't learned a lot about variables yet. But here you can reach out to the parent class from which you are inheriting by using another special keyword built into Dart, the super keyword, executed like a function. Effectively, this is calling the constructor function of the parent class then. And here you must set the named key argument to your key here, which is why I'm repeating key. This key here is referring to my named argument called key. The first key in front of the colon is referring to a named argument called key in the super class, in the stateless widget class. This would be one way of forwarding this key argument, which is what you should do here. But since you need to do this quite often, basically for all your widget classes, and this is a bit verbose if you write it like this, Dart also gives you a shortcut. You can simply write super.key here, and this will accept a named argument called key and automatically forward it to the super class, so to stateless widget, under that same name, so also under the name key. And that is something you should do here. Now I also got some more blue squiggly lines here, where in the end I learned that I should turn this into a const constructor by adding const in front of it. And this is a place where we haven't used const before. We only used it in front of values. But in the end, when we used it in front of values, we took advantage of constructor functions that had this const annotation internally. When defining your own classes with your own constructor functions, you often can add const in front of them to tell Dart that this in the end is a class that can be optimized, that can be stored in memory such that it is reused, as I explained a couple of lectures ago in this section already. So with const in front of your constructor function, you basically unlock that const is then used in front of your class when it's used as a value. So because of const added here, we can also add const here, or since scaffold and material app actually also are defined to be optimizable with const, you can even add const here in front of material app. Using that optimization technique I mentioned before in the course, now here just also with your class unlocked to be optimizable. And as always, the code editor will simply tell you when you have an opportunity to unlock such optimizations. In this case, by telling us that we should add const here, which is why I'm doing that. So that was one thing I wanted to take a look at. Constructor functions, which is a feature we'll later also use for other purposes, but which we here needed to add to make sure that this value, which is wanted by the parent class, is forwarded correctly and to unlock this potential optimization. Now, besides constructor functions, the other thing you should be aware of when working with classes is that it's considered a good practice to put them into a separate file. So here we can select this entire class and cut it, and then in the lib folder add a new file, which I'll name gradient_container.dart. And the name is generally up to you, but it should follow this naming pattern: all lowercase, multiple words separated by underscores. Dashes are technically allowed, but will actually not work, and this would be quite unreadable, so underscores it is. And then in this file, you can store your class. And we do this, we split the code across multiple files to keep every file readable and maintainable, so that all these files are relatively lean and don't contain endless amounts of code, but you instead just have one main thing per file, one main function or collection of functions, or one main class per file. Now, of course, with that added to a separate file, we got a bunch of errors in here because all these Flutter-specific types and widgets are now unknown. They are unknown because the import to the Flutter package is only here in the main.dart file. But this must be added to every file where you are using features from that package, which is why you should copy it and add that same import here in the gradient_container.dart file. And with that, all these errors go away. We still have an error in the main.dart file though, because gradient container is unknown here. This is not defined here, because it is now defined in a different file. And Dart does not automatically scan and connect all your files in your project. Instead, you have to explicitly define any connections between files that you want to consider. And you do this with the import keyword. So here in main.dart, besides importing something from the Flutter material Dart file, we also must add another import where we also import from a package, but this package is now our own project. And therefore, after package : we use our project name, in my case, basics. So here I'll use basics. This is basically whichever name you gave your project when you created it with Flutter create. So it might also be first app if you're still working in that project. Here for me, it's basics. And then here, it's the gradient container.dart file from which I want to import. And you should, of course, again, get some suggestions here, also regarding your project name. You can always open those suggestions with Control space. And then here, if I import from gradient container.dart and add my semicolon, gradient container is found again. And hence, if I save everything and reload, it still works. There is no error because we again have some valid code here, now following common best practices and conventions. Now, when working with Flutter, you will create custom widgets all the time. So it's important that you're able to do this on your own. Hence, here's your opportunity to practice this. I want you to create a separate new widget for this text part here. This should be outsourced into a separate widget, which you could, for example, name styled text, which you then use in this widget here, in the gradient container again. Create that custom widget for this styled text as explained in the last lectures, and after a short pause, which I give you to pause this video and try this on your own, we'll outsource this into a custom widget together. Did you succeed? Let's now do this together. For that, I'll first of all create a new file, because you learned that you should put your own widgets into separate files in that lib folder. And I'll name it styled_text, because I will add a styled text widget in there. Styledtext.dart it is, therefore. And then in there, we create a class, and I'll name it styled text. The name is up to you, but it should follow these conventions about which you learned. And we, of course, extend stateless widget here. Though for this to work, you also must add the import to package flutter material.dart as you learned. Now, with that set up, we must add that build method by adding override and then widget build, accepting this context parameter and returning a widget as you learned. And the widget that should be returned here should, of course, be this text here. So we can cut this from gradient container and return this here instead of styled text. Now here I got a bunch of blue squiggly lines because indeed here we can now add const again, as you learned if you hover over these blue squiggly lines, since this can be cached. This is, by the way, independent from the fact whether we add a const constructor to this widget or not. This optimization in this widget tree is detached from the fact if we unlock this widget for being optimized itself. But of course, here we should add a constructor for the same reason as before, to forward that key argument about which you learned. Hence, I create a constructor by repeating that name of the class. And then here, opening and closing curly braces to accept an argument named key. And with super.key, we then forward this to stateless widget. And here we should now also add const, since this is suggested to us here to unlock various optimizations by Dart. And with that, we have our styled text widget defined. We can now use it in gradient container. There we can type styled text and use it like this. But of course, to unlock it here, we also must add an import in the gradient container.dart file. Here we must import from our own package, in my case named basics, in your case maybe named first app, or anything else, whatever you named your project. And then here I want to import from the styled text.dart file. With that, with this import added, this styled text widget down here is found. So this here works. And if I save everything and force a reload, my application still works. And this was a nice practice for creating your own widgets. So we learned about custom widgets, a super important feature you're going to use all the time when working with Flutter. Now there's one thing you can do with custom widgets that makes them even more powerful. But before we can explore that thing, and before we then thereafter can come back to this app and add more features to that, we have to dive into variables. So what are variables? Variables are data containers, and this feature exists in basically all programming languages, because it turns out that in all programming languages you're working a lot with values, like also here, where in our styled text we have some text, or basically everywhere else we have a bunch of widgets and configuration objects, which are of course also all values. Now to understand variables, let me go back to the gradient container here. And here we could say that maybe these alignments, which of course also are values, should not be stored here in this part of the code, which is hidden quite a bit inside of the widget tree, but maybe we want to define them up here at the beginning of the file so that if we ever want to change these alignments, we can do it right here at the top of the file without having to dive into our widget tree. This is of course just a convenience thing in the end, but the more complex your code and project gets, the more little tweaks like this could help. To do this, we could cut the value from down there and instead store it in such a variable, because variables, as you learned, are data containers. In Dart, they are created with help of the var keyword, then the equal sign operator, the so-called assignment operator, and then the value that should be stored, for example, a string. So here, if I want to store this alignment value, I could create a variable here outside of my class. We can also create it inside of the class, but for the moment, let's do it outside. Then give it any name of your choice, like for example, start alignment. The name is up to you, but just as before with other names, it should not be separated into multiple words. Instead, words inside of words should start with an uppercase character. But unlike class names, the overall variable name should start with a lowercase character, so it should follow this naming pattern. And the name should describe which kind of value will be stored in that data container, in that variable. And then we assign the value with an equal sign, in this case alignment top left, for example. So that's how we could define a variable. We could then add a second variable, and that is this end variable. So therefore, I'll name this one end alignment and store alignment bottom right in there. And with those two variables added, we could use them down there to assign start alignment as a value to begin, and here end alignment as a value to end. Though here you will notice that I'm now getting an error, that a value of type null can't be assigned to a parameter of type alignment geometry. This is a bit cryptic to understand though. What does it mean? Well, variables, when created with the var keyword, which we're doing here, can actually be reassigned. Here I'm assigning an initial value, but I could then change that value. For example, here in the build method. Here I could set start alignment to alignment.center. That's a core mechanism of variables created with var. You can reassign them. Now that's in the end where this error is coming from. This null part can be confusing, but it actually also tells us that the const keyword seems to be the problem, that we might want to remove this const keyword. And here it's referring to this const keyword in front of box decoration, since if we add const here, it's also implicitly added to linear gradient, and that is the object that takes begin and end. Since the values of these variables could be changed, it's not guaranteed to be stable, it's not guaranteed to be constant. And that's exactly the kind of problem we're facing here if we do have const in front of linear gradient or box decoration. We can't tell Dart that it can cache and reuse that value because actually these variables are not locked in. They could change potentially, and therefore reusing this value would be unsafe because Dart might accidentally reuse an outdated value, which is why you can't use const here then. You could add it in front of this list still, since these colors are indeed locked in place here and hard-coded here. But that's the idea behind variables. We simply have data containers that store values, and we can define them once and then use them multiple times wherever we want later in our code, as long as that code has access to the variable, which here in this case is the case. Now, variables actually also have types. Here I'm creating two variables, and in this case here, Dart is able to infer their types. If you hover over your variable names, you see the type here, and Dart knows which type will be stored in this variable because it simply takes a look at the value you're initially assigning to the variable and uses that value's type, in this case here alignment, as a type for the variable. If you would not assign a value initially here, and you instead would only set one at a later point of time, like this for example, the inferred type would be dynamic, which is a special type in Dart that in the end just means that Dart knows nothing about the type of this variable, and it will indeed accept all value types. Typically, you want to avoid this because that can lead to bugs in your application, because without type information, Dart can't ensure that you're not accidentally using the wrong type in the wrong place. And therefore, in such cases, where you don't assign a value initially, you should replace the var keyword with the name of the type that will be stored in that variable. Here, for example, alignment. With that, Dart would have more type information, though of course here we would still get an error because we tell Dart that we want to store a value of type alignment in this variable, but initially we store no value in here. We would have to add a question mark after alignment to make it clear that start alignment is either of type alignment or null, so that it's basically optional whether it's set or not. So a null value would be allowed here. Now this would lead to more errors down here because begin actually doesn't want a null value, and therefore I'll get rid of that and just initialize it as I did it before, all in one step. But it is important to know about this alternative syntax where you do explicitly set a type and not rely on type inference if you're not initializing the variable with a value. If you do that, as we're doing it here, using the var keyword is recommended, because here you should indeed rely on Dart's type inference. Now there is more you should know about variables. For example, you sometimes have variables that never change. Of course, technically it's called variables because the value is variable, but in the end it's all about having data containers, and those data containers could also be set once and never change thereafter. For example here, I never assign new values to start and end alignment. And if you know that this is the case, it's recommended that you use final instead of var. Final is another built-in keyword, which simply means that this data container will never receive a new value. And whilst you could of course stick to var, it's always a good practice to be as restrictive as possible so that you never accidentally reassign a value here. Of course, you're the only one working on this project here probably, but in bigger teams with multiple developers working on the code, you want to be as restrictive as possible to make sure that some colleague of you is not accidentally overriding one of your variable values somewhere else in the overall project code. That's why the final keyword exists. Now here I'm of course getting some blue squiggly lines that I should use const instead of final in the end. And indeed, that's another usage of const which we haven't seen up to this point. You can create so-called constant variables or constant data containers, you could say. It's almost the same as final because const also makes sure that you can't reassign those variables, but unlike final, it provides some extra information to Dart. When using const here in front of a variable name, so on the left side of the equal sign in the end, you're telling Dart that the value that's stored in here is a so-called compile time constant, which means it's simply locked in at the point of time this code is compiled. Now that's not necessarily always the case. You could, for example, also have some code where you're maybe calling a function, getAlignment, which doesn't exist in this project, but which could exist, and which then behind the scenes could dynamically calculate the desired alignment. You could definitely have something like this in your application, and if that's the case, that of course means that this function must be executed when the app runs to get the actual alignment value. In that case, it might still be final. You don't reassign the variable thereafter, but it's not compile time constant because the value that might be returned by getAlignment is not known at the point of time when this code is compiled yet. Instead, it's only known once the code executed. And here that's different for alignment top left. This indeed is locked in at the point of time this code is compiled. Top left is clearly defined to the top left corner of the device, so to certain x and y coordinate values, and therefore you can use const to tell Dart that this is not dynamically derived at runtime, but can be locked in and set at compilation time. And this is another potential performance improvement, because if some value can be locked in at the point of time the code is compiled, this code doesn't have to execute when the app executes. Instead, this locked in and internally saved value can be used by Dart when this code is about to execute. So it's some internal performance optimization, and therefore here, when defining variables, you should also use const instead of final whenever it makes sense. So whenever you have such a compile time constant value. And just as before, the code editor will simply tell you when you have such an opportunity. By the way, with that set to const, you can also re-add const down there in front of box decoration, because now that this is const instead of var, you guarantee that it will never be reassigned, and therefore you can use const here because this code is now no longer potentially variable, because it can't be set in any other place, it can only be set once, and therefore here we can unlock this potential optimization of the box decoration object again. And in case this is all not 100% clear just yet, you will see variables and final values and constants over and over again throughout this course, but it is important to be aware of these concepts right now already, because we'll use more variables in the next lectures. So now that we learned about variables, let's use this variables feature to make some of our code more reusable. Like for example the styled text widget. We created a custom widget here so that we have this reusable styled text. But at the moment this is only partially reusable, if we're honest, because hello world is hard coded in this code snippet here. So whenever we use styled text anywhere in our application, it will always output hello world. Now the idea behind this custom widget is probably that we want to be able to reuse this configuration for this text, so the color and the font size, but the text itself should be dynamic. Put in other words, it would be better if in gradient container, where we use styled text, we could pass the text to styled text, so that this can still be set in the place where we want to use our custom widget, instead of having it locked into our custom widget. And that's of course a super common use case, because most of your widgets should be reusable and should be flexible and should be able to receive data from outside, like here, where we pass data into styled text from inside the gradient container widget. So how can we make our own custom widget reusable then? Well, with help of the constructor function. Because I mentioned before that here, when you use a class, your own one or one provided by Flutter, doesn't matter, with parentheses like this, which is how you have to use it in order to turn it into an object, you're calling the constructor function of that class. You get one automatically if your class doesn't have one, otherwise your own constructor function is called. Well, and since this is just a constructor function being called here, if we want to be able to pass input values to that constructor function, we have to accept them here. We are actually already accepting this named key argument because we had to forward it to stateless widget, but we can accept more than just that key. Either more named arguments by adding commas here and adding all the named arguments that we want to accept between these curly braces, or in addition to these named arguments, also positional arguments before those curly braces. So for example, here we could accept the text. We then should also add a type annotation here to make it clear which type of value this should be. Otherwise it's dynamic, and we typically want to avoid that, as you learned. And here it would be some string which we want, some text. And with that, we now are able to pass some text to styled text. This works. However, with that, we are not using this text in here. We are accepting the text here, we're passing some text to styled text, but this text argument, which we are accepting in our constructor function, is now not being used here. Instead, we still have the hard-coded hello world down there. So how can we use this argument? Well, not by using its name here. If we try to do that and we use the name text down here, we get an error. We get an error because this argument, which we accept in the constructor function, is not magically available in some other method of the class. These two things are detached from each other, even though they're in the same class. This is just how that works. Instead, what we have to do is we have to add a so-called class variable, a so-called property to this class. So a variable, just like the variables we added before, but now not outside of a class, but instead inside of the class to which they should belong. So here, for example, a variable called output text or just text. It can be the same name as this argument. That's no problem. So we can add this, and if we don't set it to a value, as you learned, you should instead define the value type here instead of using var. So here I'm just writing string text. And with that, we added a variable to this class. And this variable is now available in all the methods. Of course, I'm still getting an error down here, but here the error is now actually a different one than before. If I remove this text variable and we take a look at this error, we see that now it doesn't even find anything called text. Which makes sense because, as mentioned, there is nothing named text. This argument here doesn't count because the constructor function and this method is not connected. If I add this variable here, I get a different error. It's no longer saying that text is not known. Instead, it's, well, complaining about some other things here. The reason for that is that now we do have this variable, but in the end, this variable is still not set to the value we receive as an argument here. To do this, we got two main ways. We can again add this colon here after our argument list. And then here we could refer to this text variable by its name and set it equal to this text argument we're getting here. So text equals text might look a bit strange, but the first text here refers to the text variable. The second text here refers to the text argument. So if I use different names here, like output text here and here, this becomes clearer, and I would also have to use it down here. So now we would be setting our text to this argument which we receive. However, just as before with super, this is unnecessarily verbose, and therefore Dart gives us a shortcut because this is a very common pattern that you receive a value on an argument and you want to store that in a variable that belongs to the class. You can replace this string part here with this dot, so that this says this dot text. Now you just must make sure that your variable is also called text, and also down here, of course. This is simply a shortcut which looks for a variable called text, so this variable here, and sets it equal to the argument value that is received here. So in this case, the first argument that's received by this constructor function. The this keyword is another keyword provided by Dart, and this is a keyword that's used inside of classes to refer to the class itself or to refer to the object that will be built based on the class. And we can use it here to basically tell Dart that we want to access the text variable that is defined in this class, so to say. Now, typically in Dart, you don't need to use this. If you just use the name of a class variable, as we're doing it down here in build, Dart automatically looks for a class variable with that name. But here, for this shortcut in the constructor function, it is required, because if this would not be added here, you would just be telling Dart that you want to accept some positional argument, which you name text here in this constructor function, but it wouldn't automatically look for an equally named variable in the class. And by adding this dot in front of it, you instead tell Dart that you don't just want to accept this positional argument, but that instead it should also automatically be mapped to a class variable with the same name. Now I'm just getting an error because we have to remove const, because now that we receive some text here, which is stored in a variable called text, this can no longer be marked as a potentially constant object, because the text might be changed thereafter, because this is a variable. And we also have to get rid of const down there. For that same reason, we could still turn this configuration object here into a constant though, because this is still all hard-coded. But that is how we could accept such an argument, store it, and then use it. However, here we also have a great example for using final instead of setting this to be a variable. Because this variable here only exists to store that value which we receive on this argument. We never plan to reassigning it inside of this class then. And therefore, you can actually also add final in front of the type here, not instead of the type, because we still want to be clear about which type of value will be stored here. But you can add it in front of the type to make it clear that this will only be set once by this argument that is received and will not be changed thereafter. Well, and with this done, you can re-add const here, because now this class can be optimized again, because since this will never change internally, this is guaranteed to always be the same object once it has been initialized, hence it can be cached and reused by Dart. But that's how you can accept arguments and store them in instance variables, so in variables that belong to these classes and the objects that are based on these classes, and that allows you to reuse style text with potentially different text values, so that the text itself is no longer hard-coded inside of this class. And again, that were a lot of new concepts, a lot of talking about that, but it is another crucial feature, because being able to accept and store and use values in your own classes, no matter if they are widgets or not, allows you to build highly reusable classes and widgets. So now that we adjusted this class to be more reusable by dynamically accepting input values, you can do the same for the gradient container as a little exercise here. At the moment here, we got some hard-coded colors, and whilst this of course works here and is absolutely what we need for this demo app, if this would be a bigger project, a bigger app, potentially with multiple screens, we might want to be able to reuse this gradient container in different parts of the app with different colors. And at the moment that would not be possible because the colors are locked in here. Therefore, as an exercise, you should use the new knowledge you gained in the previous lecture and make gradient container more flexible, by basically ensuring that when we use gradient container, we can pass our colors here as arguments in whichever way you want to gradient container, so that inside of gradient container, those color inputs are accepted, stored, and then used down there. There will be different ways of solving this, and I'll give you a short break here to pause the video and try this on your own, before then thereafter we'll solve this together. So, did you succeed? Let's now solve this together. As mentioned, there will be different ways of solving this. For example, you could accept a colors argument here, a positional one or a named one. Doesn't matter, it's up to you. And here I'll go for a named one to show you both approaches. And this colors argument, of course, should be of the same type as the colors down there. So it should be a list of colors. And we can simply copy this type here to set this as a type. Though, as you learned, we can even switch to different syntax, since we'll need to store this in a variable anyways, and add our variable here, or better, our final variable, our final data container of type list color, which could be named colors, and assign the value that's received on this named argument here to this parameter by using this .colors here. Now, if you tried to solve this with a named argument, you likely encountered this error here, which in the end tells you that the problem now is that this is optional where it actually shouldn't be. The reason for that is that named arguments by default are optional with Dart. You can solve this by adding required in front of this. Now, most likely, you simply went for a positional argument because that's easier to use, and that's what we used before, and that's of course totally fine. I just also want to show you this alternative that if you want to use a named argument, you can do this as well, but you have to add required in front of this. And here I'm keeping this approach so that you now know also about this alternative and how you can use named arguments that are actually not optional, because by default, as mentioned, named arguments are optional. So now with that, we got our colors input. We're storing it here in this variable, and we set this to exactly the type we need. And then of course we could use that down there as a value, like this. Now I have to get rid of const here, because colors here actually is a list. Even though it's final, it's still a list, and lists by default in Dart can be edited. They can be mutated even if they're final, which is a bit more advanced and not too important right now, but for that reason you can't have const down there. And you can see this if you hover over colors down there, you in the end get that hint that you should remove the const keyword. So that's what we have to do here then. That's one way of solving this. Now I'll copy this entire widget and comment it out so that we can still see the code, but it's not active anymore. And I'll paste it in again above the commented out widget to show you an alternative approach. Because of course, instead of accepting such a list of colors, you can also accept two individual colors. You could, for example, accept two positional arguments or two named arguments, totally up to you. Color 1 and color 2. That could be the names. And both should be of type color, of course. Then we would need our variables, or again better, our final values here, which should be of type color, color 1 and color 2. And now we can use these shortcuts with the this dot notation here, just as you learned it before. Again, this would accept some input values and store them in some variables. Now the difference is that we don't accept a list of any kind of values and any amount of colors, but instead exactly two colors, which are both required because positional arguments by default are always required. And now we can use these colors, color 1 and color 2, down there in this list. And with that in main Dart, you can then pass your colors to gradient container. If you took the first solution with that list of colors, you would pass your list of colors here. If you took the second solution instead, you would pass your two colors here. So again, here I'll just quickly use deep purple as a starting point, and then use this color picker to pick some dark blue purplish color, and then copy that, add a comma, and set my second argument here, which is also a color, which is a lighter purple color, like this maybe. And with that, I'm applying these new colors to this application here, now with my reusable gradient container component. And again, this component here is reusable because I'm accepting these color values dynamically as arguments, I'm storing them, and then I'm using them in my build method. And this is a pattern, as mentioned, which you'll see a lot throughout this course, that you're building reusable widget classes. Over the last lectures, we had a look at many new features, many core concepts you use a lot when working with Flutter, but now it's time to continue working on the actual app and what we see there. And of course, there the goal is to have a button which we can press to roll a dice. And therefore it makes sense to, as a next step, show a dice on the screen, show some dice images. For that, attached to this video, you find a zip file, which you can download and extract, and in there you find a couple of image files. Now you should add those files to your project in order to then use them in your code. For that, in your project folder, add a new folder, which can be named Assets. This name is up to you, but Assets makes sense since we're about to store some images, some assets that we'll use in this application. And in this assets folder, you could even create a subfolder called images in case you had other kind of assets in this project as well, which we don't have here, but still it doesn't hurt to have this subfolder structure. Now you should drag and drop all those image files which were attached into this images folder in your assets folder. And in order to use them in your code, in your project then, you also have to go to the pubspec.yaml file. And in that file, scroll down until you find this commented out assets part here. Now you can comment this in by simply removing these hash symbols here. And you should make sure that you have one level of indentation here by hitting the tab key. And then you add a list of all the assets, all the images, for example, that should be available in your application. Just adding these files in your project folder is not enough. If you want to be able to display these images in your app, you have to register them here. And for that, you have to specify a relative path, the relative path to the images that should be included. So in my case, assets, since I have this assets folder, /images, since I have that images subfolder, and then the name of the images, dice1 PNG, but then also dice2, dice3, dice4, dice5, and dice6 PNG. All these image paths should be added here to assets in your pubspec.yaml file. Now with that added, you can use those images in your code. And here we could do this in gradient container instead of this text. Because this text here is not needed right now, instead here I want to output one of these images. And later we will add logic to change this image dynamically. Now to output an image, we can use the built-in image widget, which is provided by Flutter. You can create it like this to then set an image, but for that you need a so-called image provider, which is another object which in the end resolves to a certain image. This could be done, but if you have a locally stored image, so such an asset which we just registered in the pubspec.yaml file, there is a quicker way of referencing that. You can use image dot and then the asset constructor function. Now this is using a feature built into Dart where you can define multiple constructor functions in a given class. We could do this in our own classes as well. For example, here in gradient container, we have this default constructor function, but we could also add a second constructor function by again using our class name, and then dot, and then the actual constructor function we want to use. For example, purple, to then, for example, set color 1 to some hard-coded deep purple value like this. And then separated by a comma, you could and should also set color 2 to some predefined value, like colors indigo. Then you could add cons here, and also accept that named key parameter. And now you would have an alternative constructor function that can be used whenever a gradient container is used, so that instead of using it like this and passing those specific colors to it, you could use the purple constructor function, which here could act as a convenience constructor function with some predefined colors. And it's totally up to you what you would want to do in such additional constructor functions. Here I'll go back to the previous usage, but it is important to understand that you can simply add multiple constructor functions to the same class. And that's in the end what we're using here with this asset function. Image has a default constructor function used like this. and then multiple alternative constructor functions, which simply make adding an image a bit easier. For example, here, when using the asset constructor function, you pass a string to it, the name of the image, or to be precise, the path to the image, which in this case would be assets, image, and then, for example, dice2.png. Now here I then get an error, because actually I should remove the const keyword, because this image widget is in the end a dynamic widget, which isn't guaranteed to be const, so we must remove this const keyword to avoid errors. But with that, we have this image here, and since we now got rid of that styled text, we can also get rid of this import. And if you now save everything and force a reload of the application with this image added here, you should also see an image here on the screen. Though in my case I got a typo here, this should be assets/images. The correct path, of course, is important. And with that, I now see my dice here. Now it's a bit big, and thankfully the asset constructor function allows for additional configuration by adding another argument to it. In this case, the width argument, which you could, for example, set to 200 pixels. And with that, this looks much better, and now we have a smaller dice image here. So this is how you can display images on the screen, and this is how you can work with multiple constructor functions. Now having this dice image here is nice, but we of course also want to have a button below that which can be pressed to roll the dice. And therefore we should of course add such a button. To do that, it's no longer enough to just have a single child in this center widget, but instead we need multiple widgets here. Now center only has this child argument though. I mean, it has other arguments as well, but those don't take any widgets at all. So it only takes one single widget. So what can we do now if we actually want to provide multiple widgets as child widgets here? Well, we need another widget in between, the column widget, which is another key widget that you will be using a lot when working with Flutter. The column widget exists to allow you to render multiple widgets, multiple children above each other. There also is a row widget which would do the same but next to each other, horizontally. Here I want to have widgets above each other vertically, and therefore column is the right choice. Now the children argument which can be set here then takes a list, so we need opening and closing square brackets, and it takes a list of widgets. So therefore here we can now take our image and move that into that list here, and then below that image we can display our button. Now of course buttons are a very common type of widget, and indeed Flutter supports 3 different main buttons. It has the elevated button here for displaying a button that has a background color and a slight shadow. It has the outlined button for displaying a button that has no background color but a border. And it has the text button for displaying a button that is only some pressable text. And that's the kind of button I want to display here, though of course you can play around with that and also give other buttons a try. Now when I use auto-completion here, so when I hit tab after selecting text button, I automatically get 2 named arguments added here, child and onPressed. Now child is the simpler one. Child simply wants another widget which is wrapped inside of that button. And typically that's a text widget which holds the text that should be shown on the button. Because of course this text button should show some text, otherwise you wouldn't see anything. So here this could for example be roll dice. Now I get some blue squiggly lines here because here we can add const to allow for some optional caching. But what is this onPressed argument all about now? Well, onPressed actually wants a function or null as a value. And that is something new. Up to this point, we worked with a lot of different values, with text, with numbers, but also of course with many objects and widgets, but we never used functions as values. But you can do that in Dart. Functions in Dart are also just objects. So if you define a function, you can pass a function as a value two arguments that want a function. And here for onPressed you have two main options. Option 1 is that you define the function just in place. This is done like this, by adding opening and closing parentheses and then opening and closing curly braces. This is a so-called anonymous function. It doesn't have a name, like click handler or anything like that, and it doesn't want a name. Instead, this function is defined here in this place where a function is needed, so that it's provided as a value to onPressed. This function is then executed, called internally by text button when it registers a click on the button. So this function is only used here, can't be used anywhere else, and that's why it doesn't have a name. But between those curly braces, you can define any code you want that should be executed when this function is called, so when this button is pressed. That's option 1. Option 2 is that you define a method, for example here, after all our constructors and these variables, and that could be a method called roll dice, as you always did by providing a name and then also a return value, which in this case should be void because onPressed wants a function that returns nothing. So therefore here you should have void, then your function name, and then here whatever code you want to execute. And now you can use that function name and use that as an argument value here. So you don't execute the function here, you don't add parentheses, you just use the function name to basically pass a pointer to that function as a value to onPressed. With that, onPressed knows where to find this function, and internally, text button will execute that function here when the button is pressed. Now, I personally typically prefer this approach of having a separate function that's then passed as a pointer, so to say, by using the function name, but you could also use this anonymous function instead. But here I'll go for the separate function. And now here inside of roll dice, we can do whatever we want to do when this button is pressed. If we save everything and reload, we now see this button here. It looks a bit strange, it's at the top and the button styling isn't final, but as you can see, it can be clicked. Now it's time to fix the styling and then do something when the button is clicked. So let's fix the styling of this here. For that, I'd like to make sure that it's back in the center, and this button also should look differently. Now, regarding the center part, it's of course strange that it's not in the center because it's still inside of that center widget. But here it's important to understand that this column widget, by default, takes all the available vertical space. It is indeed centered horizontally, as you can see. It's in the center regarding that, but vertically, column simply takes the entire available space, and therefore there of course is simply no way of centering it vertically. So in order to make sure that this is centered vertically, we must make sure that column does not take the entire vertical space. And this can be done with help of another argument that can be set on column, and that's the main axis size. The main axis for a column is simply the vertical axis. And here you got two main options, main axis size.min and main axis size.max. These are two predefined values which you can use. And the default is max to take as much space as possible. Here we therefore want min. And with that, if you save this, this is centered vertically. Now for the styling of the button, we of course also want to change this. And that can be done by adding the style argument to the text button. And actually you should move that in front of child, not because you technically need to, but because that is one of the patterns recommended by Flutter, to always keep your widget arguments last. Now style here wants a button style value, and the easiest way of creating this for a text button is to use text button style from. That's in the end a function defined on this text button, which returns a button style object. And style from now takes various arguments, which you can use to override the default styling. For example, you can set the foreground color to change the default text color, because the foreground color of a text button is the text color in the end. And here you could set this to colors.white using this predefined color. You can also add a separate text style, which then wants a text style object using this text style constructor function, which we already before used for styling the text widget, so this constructor function. And there we could also set the text color, but I'll just use it for setting the font size to 28 here. And this can now also be constant here. And with that, this text is a bit bigger and white. Now I'd just like to have more spacing between the image and this button, and for that we have two main ways of doing that. The first option is to add some padding on this text button, which you can do in this style from function by setting padding. Padding simply is some spacing inside of the widget between the widget content and the widget boundaries. And this padding can be set here for this text button with the padding argument in the style from function, and it wants a edge insets geometry object type. Such an object can be created with the edge insets constructor functions, which are suggested to me here. For example, edge insets all adds a certain amount of padding into all directions. You can also add padding to just the top by using the only constructor function instead, and there passing the top argument, the named top argument, which then must be set to a number, like for example 20 pixels. This can also be turned into a constant value by using const here. And if you do this, there is more spacing around this button. Now, the alternative approach to using this padding setting here, which is absolutely fine, I just want to show you options, is to comment this out and instead add an extra widget between the image and the button. And that would be the sized box widget, which kind of does what its name implies. It simply creates a box of a certain size. And you can add a child widget in there if you want to. But most importantly, you can also set a height and a width here. And here we could set this to a height of 20, and then also add const, since this can be added for this widget. And that would also add a widget of this size between the image and the button, hence adding this extra spacing here. Now we don't see any widget here in between, because this sized box doesn't have any content. It's really just a widget of that size, of that height, that just takes up that space without showing anything on the screen. And that's also an important difference between sized box and other widgets, like for example container. Container and most other widgets simply take the width and height they need to take to fit their content into themselves. For example, a text widget is just as high and wide as needed to show the text on the screen, so that it's not cut off. On the other hand, with sized box, you explicitly set a certain height or width, and that height or width is then set in stone. If you would have some child widget inside of sized box, that child widget and the content of it would not lead to sized box becoming wider or taller. Sized box has a fixed width and height, and if it would have some content that doesn't fit into there, because it, for example, needs more width, that content would be cut off. And that's an alternative to adding padding. You can use whichever approach you prefer. So now that we got the styling right, it's time to make sure that something happens when this button is pressed. For that, of course, we have this roll dice function which we connected, but in there we're not doing anything. Now for a start, let's simply say that in there we want to switch this image from dice 2, or whatever you used as a default image here, to let's say dice 4. So this should switch as we click this button. To achieve this, we could add a variable to this class, a real variable that can be changed, because now we do want to change things. We could add a variable with the var keyword and name this our active dice image. Anything like that. That could be our name here. Now, of course, this also should have some initial value, so we can set an initial value here. We don't have to do this in an uninitialized way. We can instead initialize this here, and for example, set this to this image path here. That could be what we want to do as a start. Now, with that, I can no longer add const here because I brought back a variable, and if we have a variable in there, this is not a const class anymore. We can't create constant objects with it anymore that could be stored and reused from memory, because now the object can change internally because we have that variable which could change and which we indeed intend to change. And we can ignore these blue squiggly lines and this message here for the moment. So we have this variable, and here in roll dice, I then want to set active dice image to, let's say, the same path, but with dice for PNG. So that's now the goal. We have this variable, we're changing this variable here then, and we can then use this variable down here instead of having this hard-coded path. And this, of course, also is a great example showing us why we might want to use variables in some situations, because now we really do want to have one and the same data container, which we can reference here, which will hold different values based on the circumstances. This value here initially, and this value after clicking. And if we save that and in main Dart actually remove const here, because we had to remove const from gradient container, we can add it in front of these colors though. But if we do that and make these changes, which we just discussed, to gradient container, save this and reload, we got this. But if I click this, nothing happens. So maybe this function isn't executing, right? To find out if it is, we can add print here, a built-in command provided by Dart, which we can use for outputting some information in the debug console, which is a console we as a developer can have a look at whilst we're testing this app. So here we could output some text, changing image, something like this. If we add this, we just have to go to View, Appearance, Panel. And here in this panel, we find the debug console, which would print anything print outputs here. And some additional statistics, which are not important for us right now. If I now restart this, and we go back, and I click roll dice once, I can see that changing image was logged in that debug console. So clearly that code in roll dice executed. Nonetheless, the image here didn't change. Why? Now the image here did not change despite the roll dice function being executed, because we're in a stateless widget. And this is just one of two main ways of creating widgets. And it's the wrong approach for widgets that should have internally changing data. It is absolutely the kind of widget you should use if you just have a widget that takes some input values and then outputs some widgets. But if you have a widget that has some data that can change internally, and where such data changes then should affect the rendered UI, as it's the case here, where the image we want to display on the screen in our own widget here depends on this active dice image variable, if we have a scenario like this, stateless widget is the wrong choice. We should instead create this as a stateful widget. So what's the difference? Stateful widgets, as the name implies, allow us to manage state inside of them. And state simply is data that may change over time and that should impact the rendered UI. So if the data changes, the user interface should change. We simply have different states of our user interface, you could say. So therefore here, indeed, the first step is to convert this to a stateful widget to make sure that in here the data may change. Though to be precise, it would be a bit overkill to change the entire gradient container to a stateful widget, since the majority of this widget actually does not depend on that changing data. It's really just this part here, this image, and the button. Only these things work together to change the image. The rest of the widget is pretty stable. Therefore here it would actually be preferable to break this widget up into two separate widgets. One stateless widget, this one, and one stateful widget, which contains the image and the button. And that is what I'll do here to keep the overall code organized. For that, I'll add a new file here, which I'll name dice_roller dart. Because in there, I want to create a widget called dice roller, which will be that stateful widget we're about to create. Therefore, dice roller should extend stateful widget. And in order to do that, we here also must import package flutter and then material dart. So it's still the same import as before, but now we extend stateful widget here. Now this class here, dice roller, which extends stateful widget, now is defined in a different way than we did it before for the stateless widget. Here we don't add a build method. We do not do that if we have a stateful widget. Instead, in here, we must add a create state method. So a method called create state, but just as with build, we should add the @override annotation here. Because that's basically another method we're forced to implement because we're extending stateful widget here. Now create state does not take a value here, but it actually returns a value. It returns a state object. Now that's a type built into Flutter, provided by Flutter, and state, like list earlier, is a generic value type. Hence we have to add these angle brackets to basically inform Dart which kind of state will be managed here. And here it should be the state for the dice roller class, for the dice roller widget. Therefore, the value passed between those angle brackets should be your class name, dice roller in my case. And in the body of this create state method, you then have to return such a state value, so a value that has this type. And this value is created with yet another class. When using stateful widget, you will always work with two classes. This is the first class here, and then you must add a second class, which typically should start with an underscore, and I'll get back to that in a second, and then dice roller state. So the convention is to pick up your widget class name and append state at the end and start with that underscore, that leading underscore. This underscore has a special meaning in Dart. It means that this class will be private. It will only be usable in this file. Even if you import this file into another file, that other file will not be able to access this state class here. And the reason for that is that this state class is really only meant to be used internally by this dice roller widget class here. Now this state class here also must extend something, and that something is state again. So this state value, though here again we have to embrace the fact that this is a generic type and add the angle brackets, and here in between again we add our widget class name, dice roller. So we extend this state class adjusted for our widget class name here. And inside of this state class, we now have to add that good old build method again. So stateful widgets are in the end split across two classes. And the reason for that is simply that they're managed in a special way internally by Flutter. Flutter essentially requires these two classes to be detached from each other. Now the build method works just as the build method in the stateful widget though. You add @override, you return a widget, so a value of type widget, you will get this context parameter, and then here you return your widget or widget combination, your widget tree. In my case here, that means that I want to return this column here. So I'll select this column, taking advantage of these nice annotations which are shown in my code editor here because of the Flutter extension that we installed, telling me where the column widget ends. And I cut this from gradient container and instead return this here in dice roller state, adding a semicolon at the end. And with that, we have this separate state object. Some things are missing here. We'll take care about them in a second. But now here in dice roller, in this create state function, we now call dice roller state with that leading underscore as a function. So we basically execute the constructor function of dice roller state. We haven't added a constructor function here, but as you learned, Dart automatically adds one by default in case you don't add one yourself. Speaking of constructor functions, we should add one here to our widget class to set that key parameter again. So to accept this named key parameter and forward it to the superclass to stateful widget. That's the same as for stateless widget. And then we can also add const here. We can do this even though a stateful widget by definition is able to change internally because we have this class separation. And internally, Flutter in the end makes sure that the state object can change, which is why we don't add a const constructor to that, but the widget will be kept constant by Flutter. It will take care of that for us. So now we just need to make sure that this variable and this roll dice function are there, and therefore we can go back to gradient container, and in there take this variable and this function and cut it from there, which then also allows us to bring back const here because we removed that variable, which also allows us in main Dart to bring back const here and remove it in front of the colors. But more importantly, we can go to dice roller, to this dice roller state here, and there add both the variable and the roll dice function. And we can get rid of the print statement here now. With that, we have the variable here and this function. And therefore now we just have to make sure that we use the dice roller widget, which then is connected to that state, inside of gradient container. So there, I'll now use dice roller and instantiate this like this. And of course, to make sure that it is available here, we have to add an import, because you always have to import what you use in a file. So here I import from package basics, and then here diceroller.dart. If you save this and force a reload, you should now be able to click this button and change from a dice with 2 on it at the beginning to 4. Except for that it doesn't work. So what's missing? I mean, we are using a stateful widget after all. And indeed you must use stateful widget, but that alone is not enough. Of course here we have a variable which we change, but even that is not enough. Instead, by default, Flutter will simply ignore that. You change your variable, that's good, but that does not lead Flutter to re-execute this build method and re-evaluate the UI that it should output. And it must re-execute the build method to pick up any changes to active dice image. Because in here we have the code for displaying the image, and if active dice image changed, the image on the screen will only be updated if the build method executes again, so that all this code is re-evaluated. Because otherwise, if build never executes again, it's still this initial UI snapshot that will be output that was based on the previous value of active dice image. And that's a really important concept in programming in general, actually, that you should understand. If you're using a variable like active dice image here in your code, the code in which you use it, so in this case the build method in which we use it, does not magically re-execute just because you changed the variable value anywhere else in your code. This is not happening here, and this is not happening in other programming languages either. Instead, the value stored in this active dice image variable is only considered and used if the code where this variable is being used executes. So for example, when this build method executes for the first time. And the build method will execute for the first time when this widget, this dice roller widget, is rendered to the UI for the first time. And that in turn will be the case when the widget in which dice roller is used is being rendered, which ultimately all comes down to the run app function in the main.dart file, because that's where the entire UI widget tree starts being created. So that's when the build method here in dice roller executes in the end, and that's when Dart takes a look at active dice image and takes the currently stored path into account for, in this case, rendering an image on the screen. And initially, when this build method runs for the first time, because this widget is rendered for the first time, Dart therefore uses this dice2 image, which is the initial value for active dice image. So if you then change that variable value and you want Dart and Flutter to update the UI and take this latest variable value into account, you must find some way of getting Flutter to re-execute this build method of this widget, or of this widget's state in this case here. So how do we get Flutter to re-execute build? Well, we have to call a special function in the place where we update a value that is used inside of build and that will lead to some different UI output. We have to call the special setState function, which is available inside of state-based classes. So inside of dice roller state, since we extend Flutter's state class here, we have a setState function which we can call. That is provided by this state class provided by Flutter. We have to call setState here inside of roll dice, and to setState you must pass a function. And here you typically pass an anonymous function, as I mentioned it earlier, related to the button. Inside of this anonymous function, you should now perform any updates to class variables, to object variables, that should be reflected in the UI. Because setState, this function which is provided by Flutter, in the end tells Flutter that it should re-execute the build function of this state in which you call setState. And if after executing build, Flutter determines that you now expect a different UI than what you had before, it will go to the actual app UI and update it in all the places where updates are needed. So for example here, after setting active dice image to a different path when calling setState, Flutter will re-execute build, and indeed here, where we use active dice image, it will now see that a different kind of image should be displayed on the screen, hence it will go to the real UI that is active on the screen and update the image in there. And with that, with setState added, if you now save this and force a reload, you will finally be able to click roll dice and you see the image changed to a dice that shows us 4. And that's how you build stateful widgets and how you make sure that you can update the state, and such state changes are then also reflected in the user interface. So we now added our stateful widget, and with that we can click this button to change this dice here, the dice image. But of course, at the moment, we can only click it once. I mean, we can click it more often, but we always set it to this image that shows us a dice roll of 4, and that's ultimately not the goal here. Instead, we want to generate a random value between 1 and 6 and update the image appropriately. Now, to get there, we'll have to do a couple of things, and most importantly, we have to generate that random number. Now, that can be achieved with help of a feature provided by Dart, which we have to import though. We have to add an import where we import something directly from Dart, and there from the math sub package. So this is now not a third-party package that would have to be registered in the pubspec.yaml file. Instead, this is really from Dart itself, but a Dart feature that is not available in all Dart files automatically out of the box, but which instead has to be unlocked in a file by adding this import. Here we want to use a math feature provided by Dart. To be precise, here in roll dice, I now want to use the random constructor function, which is provided by Dart's math package, to create an object that has various methods that help us with the generation of random values, random numbers. Here, for example, the nextInt method. NextInt can be called to generate a random integer, and for that, nextInt actually wants an input, an argument, which is the maximum, the highest possible integer that should be generated, though that value, as we can read here, will actually be excluded. So if we pass in a value of 10, for example, we would generate a random number which is greater or equal to 0 and smaller than 10. So here, if I want to generate a number between 1 and 6, I can pass in 6, and that would give me a value between 0 and 5. So to make sure that it's between 1 and 6 instead, I simply have to add 1 here. And that would then give me a number between 1 and 6. So that generates such a random value. And we could now use that random value and store it in a variable called dice roll, for example, to then dynamically set this string here, this path to an image. So in the end, what I want to do here is I want to replace this number, because my images are all named dice1, dice2, and so on, so I just need to replace this number here with my number, which is between 1 and 6. And it must be between 1 and 6, because I only have images for 1 to 6. Now getting such a number here into a string is pretty easy with Dart, because it gives us a nice syntax, a nice feature that allows us to kind of inject values into strings. We can add a $sign here, followed by the variable name that holds the value that we want to inject into the string. So now this will dynamically construct a path, which is assets images dice dash, and then whichever number is stored inside of dice roll. That's what this special syntax does. It injects the dice roll value into this string. So when we set active dice image to an image path, this path will include the actual number that was generated here. That's one way of doing this. However, we don't actually even have to store the entire path as state here. Instead, we could get rid of that active dice image variable here, and instead just add a new variable that could be named current dice roll, which initially maybe is 2. And then that's the variable I want to set here in set state. And I want to set current dice roll here equal to my dice roll variable here, or actually make this a bit shorter, get rid of that extra variable, and just generate my random number here and use it here to then update current dice roll inside of set state. So now I just managed the dice roll number as state, and that allows me to then grab this path which sets the dice roll dynamically, or which injects that dice roll, and use that down here. And instead of using dice roll here, I now want to use this current dice roll variable, which we do update inside of set state. It's up to you which approach you prefer, but this keeps our state a bit leaner, a bit easier to understand, since we're just managing a number here, and then we dynamically derive the actual path based on that state value, so based on that number, whenever build is executed, and as you learned, build will execute when we call set state here. With that, if we save everything and force a reload, we should be able to click this and generate different dice rolls. Now, of course, you might sometimes roll the same number twice, so simply click this a couple of times to see some differences on the screen. So that's our different dice rolls showing up on the screen here as we click this button. But the current approach still isn't optimal, because at the moment I'm always creating a new random object here whenever roll dice is executed. And whilst this works, it's a bit redundant, because technically this means that every time roll dice is executed, so every time we click the button here, a new random object is created and stored in memory, so in the memory of the device that is running our app. And the old random object that was created there before will be thrown away. Now, thankfully, it will be thrown away, so therefore at least we don't occupy the entire memory at some point, but still that is some redundant object creation and deletion in memory, which is not a problem for this basic app, but something you might want to avoid. And of course, my goal with this course is not to teach you any way, but if possible, the best possible way of solving a certain problem. And therefore here it would be better to cut this random object and instead create a new final value here. Randomizer could be the name, which stores this random object, which we then use here. And actually, this doesn't even have to be inside of our state class here. This could even be defined outside of it, maybe here, right below the imports, because it's totally fine if this is only created once when this code file executes for the first time, and it doesn't have to be re-executed every time the state object is created. Technically here, the state object shouldn't be recreated, but still there's no need to keep the randomizer inside of this class here in this application. We can instead set it up as a globally available final data container here in this code file by adding it right below the imports and then still referencing it by name down there. And with that, we should have the same result as before, that we can click this button and change the image, but now it's a bit more efficient. And that's it for this course section. We built this roll a dice app here, where we can press a button to generate a random number between 1 and 6 and show different dice roll images on the screen. And whilst we built this application from scratch, starting with an empty main.dart file, we of course had a very detailed look at many core Dart and Flutter features you will need for basically all Flutter apps you're about to build, and you will need as a foundation for the rest of this course, of course. Now, as mentioned, it all started with an empty main.dart file in this lib folder in a new Flutter project, because it's this main.dart file that is evaluated as the first file when your Dart Flutter app starts on a device. Now, of course, you in this section learned that technically this Dart code which you write in that main.dart file and in the other Dart files is not executed like this when the app starts on a device, but instead after development, when preparing it for publishing, Dart parses your code files from top to bottom and then compiles that code to native iOS or Android machine code, and it's that machine code that's then shipped to those devices, so that's then in the end installed from the app stores, for example, and it's therefore that compiled code that is in the end executed on those devices. Nonetheless, you as a developer write your code with Dart and Flutter, and therefore you learned that indeed it starts in the main.dart file, and there it starts with the main function. And functions are one of the core concepts you learned about in this course section. Like many other programming languages, Dart allows you, the developer, to create functions which are simply custom commands. And you can of course not just create functions, instead you can also use functions that are built into Dart or provided by Flutter, which is a Dart framework in the end. And that's exactly what we're doing in this custom main function here. We're executing this run app function, which is provided by Flutter, and which is why you have to add this Flutter import to your main Dart file to unlock these Flutter features like run app in this file here. And it's then in the end the combination of that main function in the main Dart file being executed automatically by Dart, and that run app function that's provided by Flutter telling Flutter what should be drawn onto the screen. So which kind of user interface should be displayed on the screen. And for that, run app needs a so-called argument. It needs a widget or a combination of widgets, typically, that in the end tells Flutter what should be displayed on the screen. Because Flutter, as you learned, is all about widgets. It's all about combining different widgets in code. And that's also important. In this section, you learned that you in the end tell Flutter what to display on the screen by using these so-called widget things in your code, like material app, scaffold, center, container, and many other widgets, including custom widgets, which we also built in this section, which you can use in conjunction to all these built-in widgets that are provided by Flutter, like for example the buttons or various layout widgets that are provided by Flutter. In addition to those, you can also add your own widgets, as you learned in this section. And that is really important. When building apps with Flutter, you have no visual drag and drop editor for doing that. Instead, you build your UI in code. You define the user interface by writing code and by combining these widget things. And these things here are actually objects based on classes, as you learned. Because Dart is an object-oriented language, and therefore all values in Dart are objects. That includes simple values like text or numbers, but it also includes more complex values like widgets. Everything is an object, but those more complex objects are built based on classes, which act as blueprints for objects. And objects are in the end simply data structures stored in computer memory, so in the device memory on which your application is running. And these data structures store data, like for example the text of a text widget that should be output on the screen, but also logic, functions that can be attached to classes, like for example this roll dice function which we added to a class in one of our custom widgets to make sure that when this button is pressed in our application, which is rendered with help of the text button widget provided by Flutter, that when that happens, when that button is pressed, this roll dice function is executed. That's why we're using classes in Flutter, especially also when creating custom widgets, as we're doing it here, to group data and logic functions together into one data structure. And that was another core concept about which you learned in this section. You also learned that Dart is not just object-oriented, but that types are important. That Dart is a type-safe language, which simply means that all the values you are working with are of certain types. For example, the text hello world would be of type string. A number could be of type int for integer if it's a number without decimal places. And the material app widget would be of type material app, because you can also create your own custom types. And for example, every class you define also automatically creates a type of the same name. You also learned that values are not just of one single type, but instead of multiple types. They are always of type object, at least, because all values are objects in Dart, but they might also be of other additional types. For example, material app is not just of the very specific material app type, but it also has the more general widget type. And this type feature exists in Dart to make sure that you're not accidentally using the wrong type of value in the wrong place. Like for example, passing some text as a value for width, when this actually wants a number. Now in this section, when building custom widgets, you also learned that there are two main kinds of custom widgets, stateless and stateful widgets, with the difference being that stateless widgets have no internal changing data, which when changed should update the UI, whereas stateful widgets indeed do support internal data that may change and where such data changes then should lead to an updated UI. Like here our dice roller widget, which in the end allows us to change the value of the current dice roll variable, and which then makes sure that this change and this updated value is reflected in the user interface by calling this build method again, which, as you also learned, is a crucial part of custom widgets. You add build methods to those widgets to define which widget or widget combination should be yielded by that custom widget, because custom widgets in the end are about combining other widgets and possibly enriching that combination with extra logic, as we're doing it here. A key difference between stateless and stateful widgets then is that for stateful widgets, you actually create two classes, a widget class and a state class, and behind the scenes Flutter makes sure that these two classes work together, whereas for stateless widgets, you just have a single class which directly contains that build method, which I just explained. And in this section, you also learned how you can leverage constructor functions, which are functions that are executed when you create a class, when you use a class, like we're doing it here with gradient container in the main Dart file, when we create this widget combination to pass it to run app. That when you instantiate classes, the constructor function of that class is executed, and this function can be used for some initialization work, but you can also use it to accept arguments, positional or named arguments, and these parameter values can then be stored in internal variables, which then can be used in the build method, for example, so that you build reusable custom widgets, where one and the same widget, like gradient container here, could be used in different places of your application with different configurations and values. And these were just the most important features about which you learned in this course section. Of course, there also were other features covered, like for example how the code editor, Visual Studio Code in my case, can help with writing code. You also learned about how const can be used to potentially optimize performance, and that thankfully Visual Studio Code tells you when you can use const. You learned about variables, which are data containers, and about final data containers, which are also like variables, but unlike variables can't be overridden or changed. And therefore, at this point, you now don't just have your first basic app that you built together with me, but you also have that solid foundation, which you can now use to dive deeper into Flutter and Dart, which is exactly what we will do in the next course sections.